All right. Can everyone hear me? This is awkward. Okay. Just a minute as I'm setting up. Cool. Looks like the stream's going through. Well, welcome everyone. We're so glad you can attend today. This is by no means our traditional format for this annual event. In the past, we've had it online. We had a cool conference where we'd host it in person. But with the circumstances as they are, we've got this free YouTube live stream for everyone. We're all trying to do the best we can do. For those of you who are new today, the Digital Entertainment Conference, or DEC for short, is a collaborative series of presentations from industry professionals in the local area in a diverse skill sets. From UI design to art to visual effects. We've got plenty of speakers here. Each speaker will be giving a presentation on topics from his or her background that you'll find quite relevant in your career as we grow as future game developers. Without further ado, I'll introduce our first speaker. So, Katie Hirsch is going to be our first speaker. She's a user interface, or UI for short, engineer at ZeniMax Online Studios, working on UI for the massive multiplayer online game, The Elder Scrolls Online. She has spent most of her career working in UI programming both in and out of the games industry, and shipped multiple titles, including The Lord of the Rings, The Battle for Middle-earth 2, Rise of the Witch King, Command & Conquer 3, Kane's Wrath, Civilization 5, XCOM Enemy Unknown, and FEAR 3. Katie has a Bachelor's of Science in Computer Science and a Bachelor's of Arts in Visual Arts, IMDA, from UMDC. Without further ado, I'll have Katie stream her presentation.
For that introduction. Sorry if I have a fuzzball in my lap. So hopefully it'll start showing me soon. Sorry, there's a little bit of a delay between when we start streaming and when we see it. There we are. Alright, so just to pull up my notes real quick, and it's Fear 3, even though it's got a bunch of dots in between it. So, yes, I am a user interface programmer. I graduated from UMBC in December of 2004, so it's been a while. I've worked at several game companies in this area, Breakaway Games, Day One Studios, Firaxis, and now ZeniMax Online Studios, that recently got bought by Microsoft. But we're still a subsidiary, we still get to keep our name and all that fun stuff, and I'm still working on Elder Scrolls Online. So, you got a little bit of my brief background. As a UMBC student, I did an internship at a place called Vision Video Games, where we worked on Space Station Sims, and that wonderful company went under while I was still an intern. So if I didn't realize the games industry was volatile, then I wasn't going to figure it out. So several of the people I worked with there got hired at Breakaway and were able to vouch for me and get me in at Breakaway Games, where I started as an artist. And after doing mostly modeling and texturing of UAVs and not getting to animate, which is what I really want to do in art, I switched over to programming. Was a tools programmer for the user interface tool, and that led into becoming a user interface programmer with my first full-length game that I did as a UI programmer, being Command & Conquer 3, Kane's Wrath. I do have on there that I did Rise of the Witch King. That was a hiatus where, as a programmer slash artist, they needed somebody to do the intro video. They couldn't give it to a designer because the designers were swamped doing their levels. the artists were not tech savvy enough to do a lot of the scripting required for it, and hey, it is a piece of art, so we're not super thrilled with giving it to a programmer. Wait a minute, Katie does both, so I had a couple of month hiatus where I got to do the intro video to Lord of the Rings, The Battle for Middle-earth 2's expansion Rise of the Witch King. So then I was the lead UI programmer on Command & Conquer. Once that shipped, Breakaway was starting to do poorly, and they lost a couple of major contracts. They had 2 major layoffs that I survived, and people were leaving in droves. I had the option to go to ZeniMax or Firaxis at the time. I went to Firaxis to work on an unannounced title that actually ended up never shipping. I worked on that for about 9 months before they shelved it and then moved me over to working on XCOM Enemy Unknown as a in pre-production / production time frame. I was one of the UI programmers on that. The guy who had been my lead the guy who I had been the lead of at Breakaway became my lead on XCOM Enemy Unknown. So never burn those bridges. You don't know who's going to be your boss someday. And really, we worked really well together. So the only difference in who was lead is who has to sit in all the boring meetings and who gets to write code. So that worked out pretty well. And then then I got moved on to Civ 5 when there was about, we were basically crunching and trying to get the thing out the door. I came on, helped a lot with their UI. And then right when it was starting to feel playable and starting to feel like I wasn't just putting out fires every day, they pulled me and 20 other people into a room and said, hey, guess what? That project that we shelved, that we said was going to come back, that you got hired for, we're not actually taking it back off the shelf again. So once Civ 5 ships, you have nothing to work on. So I got let go along with 20 other people. And within a month, got brought on at Day One Studios as a contract UI person because they were not convinced they needed another full-time UI person for a first-person shooter, because how much UI does a first-person shooter have, really? Turns out that I convinced them that with all the multiplayer screens and all of the intro screens and front-end stuff that needed to be done, they did need another UI person. So within 9 months, I got hired full-time. We shipped Fear 3. We had another project we were working on that we were really excited about. We were doing a great job. The publisher thought we were doing a great job. But the publisher didn't think there was a market for the game at some point. And so 6 or so months into production, they pulled the plug, and 70% of the staff got let go, myself included. From there, I worked at a startup for a little while doing game technology for educational software, which is really where my heartbeat is. That's why I'm talking to you guys, because I just love education, and I love the use of game technology in that space, but we just didn't get the contracts we needed. And after 2 years, I was kind of tired of not getting paid, so I switched off. I went out into the games industry. I worked at Tenable Network Security and a couple other random contract gigs in web software. And just after 3 years at Tenable, which is a great company, they do network security like your Nessus, your security center, basically software for admins to manage the security threats in their networks. And I was doing the UI piece for all of those products that would give heads-up displays that would allow you to monitor your network. It just wasn't as challenging as the games industry, and I felt my skill sets atrophying, and I was excited to get back into the games industry. Getting to be an adjunct at UMBC, hi guys, some of you might have actually been in my class at some point, helped me keep my skill set up in C++ enough that I was able to apply back into the games industry and get back at ZeniMax Studio. Actually, that was like 4 years ago, so maybe not any of you guys were in my classes, but maybe if you talk to some of your recent graduate upperclassmen, they might have horror stories of being in my class. Anyway, so that's a little bit of my background and experience. Talking a bit about the games industry and then UI programming in general. Programming, since I'm one of the only programmers speaking, Eric's going to speak later, but he's primarily going to speak about getting into the industry, I believe. So from the programming perspective, those of you who are programmers, it's not just about, I want to be a programmer, I'll take anything. There's actually a lot of various things you can do in the games industry within programming. I'm a user interface engineer, which means that anything that's a 2D layover on top of the 3D world, and we even mess with in 3D environment too, trying to raycast out for selecting objects on a screen from the pixel space into the 3D space, that kind of stuff. That's all UI. And there's gameplay engineers. They're the ones that take the underlying ideas in the engine and say, how do we build this system? That can be anywhere from supporting the effects the character is doing, to just really building out kind of systems of how the inventory is stored and works, and managing data, if you will, for the purposes of how the game moves forward and progresses. They do a lot of the state-based stuff and all of that. You've got your network/database engineer. Usually they're called DB engineers. They're basically also network engineers, because especially when you're working in an environment where most games are today, where all of your data as a user is stored on a server somewhere and has to be accessed, they're figuring out how to fit it all into the data storage space. Then also, when the client requests it, they send a message to the server, not unlike what you're going to see in web development, when you're sending, what do we call those? I don't remember the name of them, but you know, a message over the fence and saying, hey, get me some information, and then you as a client are waiting for that information to come back to you. The database engineer is going to figure out how to query into the database, collect all that data, send it back to the client in a way that doesn't bring the server to its knees, because there's hundreds of users doing this all the time. So they're managing all of that information. Then you've got combat engineers at where I work, and their job is entirely around supporting what the combat designers want to do. That's the look and feel and how powerful, swords are and abilities are, and how to, the designer sitting there balancing the powers and everything, and the buffs and debuffs and all of that, and the combat engineers are supporting that and saying, all right, this is what they want, how do we make all of those work together and interact with each other under the hood in a successful manner, so that things behave the way that we thought they were without any kind of unexpected circumstances happening. Then you've got a tools engineer. Tools engineers are mostly the only guys that are not spending a lot of time in C++ like other programmers in the games industry, with the maybe exception of a lot of UI people will spend a lot of time in scripting languages, but we also touch the C++. A tools engineer will almost entirely be doing their work in C# usually, or some variant of that. A tools engineer builds stuff that you never see, the user, the end user never sees. They're building basically tools that the content developers or the artists or even other programmers will use to develop content within the game. Because obviously, when we want to make a new sword or something, we as programmers don't want to spend time coding all of that. We give those apparatuses to the designers so that they can use data to put in those new items, and we don't have to be, as programmers, involved in that pipeline. In order for us to do that, we need a tools engineer that manages the tools that those content developers are using. So they're kind of, the hard thing about being a tools engineer is that your job is never done. There's never the tool is done as it's shipped. You're always maintaining it, you're always supporting it and supporting the people who are constantly using it. But it's a kind of fun way to feel like a service provider to the people who need to build the content. So it can be really rewarding in that aspect. And that can range from animation tools to audio tools to how to manage data for monetization, to how to set up things in the world, to how to navigate nav meshes, to you name it. So you could touch any part of the game as a tools engineer. Graphics engineers, most of you have taken graphics, or it's on your list to take, because even if you're a UI engineer, you need to understand graphics, because you need to be aware of how things work in a 3D environment even if you're not working in the 3D environment every single day. The graphics programmers, they're knee deep in all that. They're the ones writing the shaders to make things look pretty and awesome, and also supporting how the game engine talks to the graphics card and does all of that, and supports make sure that the game supports all the options for all the various graphics cards that are out there, also making it compatible with any consoles that we're working with. Then you've got the audio engineers. The audio engineers, those are people who are usually supporting the audio programmers, making sure that they have the tools they need to get their stuff in the game. That's often mixed with tools programmers. But they could also be doing special things under the hood to make sure that the mixing works. How we fade in and fade out sounds when you go into a really intense area or leave that intense area. How that ends up mixing along with the sound effects of your character hitting the ground, or swinging their sword, or various other things, or the clicks that we see in the UI, and trying to make sure that those overlays and those transitions happen in a smooth way, and managing all of that. You have also things that often will be set up so that a designer will put maybe a sound emitter somewhere in the world, and the audio person will control either, building that type of emitter that a content developer can use that can manage, well, how far away are you going to start hearing the sound? How quickly does the sound ramp up as you get close to it? And how does it mix with the other things around it? So that's your audio engineer. Then your systems engineers they can be very intertwined with gameplay engineers. They're the underlying systems. For example, something like in ESO, Elder Scrolls Online, that I work on, we have what's called a justice system. This is the system that if you steal something from somebody in the world, you get a bounty put on your head. So, and you have to, do certain things or wait a certain amount of time for that bounty to be removed. There's an entire underlying structure on how that system interacts with other systems and works under the hood. Systems designers will come up with that concept. System designers and designers in general spend most of their time in Excel and Word. I know that sounds really super boring, but that's what system designers do, because they're trying to come up with all the details of how the underlying system will work and interact with existing systems and that kind of thing. And then the system engineer builds all of that infrastructure so that it can integrate in, because we want something that is encapsulated and maintainable within each individual system, so that it's not just a bunch of disparate code all over the place, because then you can't maintain it. And particularly when you're working on a game that is live, maintainability is huge. So that's just a little overview of the types of things you could do as a programmer in the games industry. Now, moving on to what are we talking, as a programmer and having been a teacher over there, one of the most difficult aspects of the job that I have to both learn and to teach is debugging. I'm sure you've all done it on your projects. Debugging is trying to go through the code that exists and figure out what's really going on. Now, when we put code together, where I'm at, or just about anywhere I've worked, usually there's a code review process. So it's for the purposes of the academics you're in, you have an honor system, do your own work, don't rely on everybody else, it'll just cripple you in the end when you have to be able to stand on your own 2 feet. So make sure you do your own work. However, do not let that honor code system turn you into a my code you can't see it kind of person, because that's not how the industry works. We work very collaboratively, and your code will be touched by others, touched by you maybe 6 months later, and everyone's code gets reviewed before it gets checked in. There's no I'm going to slip this in and it's going to be cool and everyone's going to suddenly notice it tomorrow. It has to go through a review process, and people will give you comments on, hey, is this algorithm working correctly? Does this match our coding standards? What have you. When we approach, in my team, working on debugging, the key is to figure out not just what's happening and what code will fix it, but why is it happening? Is there a deeper underlying cause? Because our QA is working in what's called black box testing, which means that the inner workings of the game are abstracted from them. They can't see it. They're only seeing the end result that the end user sees. So if they say, hey, there's this thing that's a little weird here on the surface, that may be the only alert that we have as programmers that there's something wrong deep down in the system that may not manifest visually on the screen. And so it's important when we get a bug, not just to make sure that bug goes away, but to make sure that it's not a symptom of a deeper issue that needs to be addressed and solved. So whenever my team, we put up code for review, the top question is not just, it's what was happening, why was it happening, and how does this address that? If it looks like a Band-Aid, we don't want it. We want code that's maintainable, so we want something that really fully understands the problem. And do this in your projects too. If you start hunting and pecking, put something in, compile, did it run? Put something in, compile, did it run? That's walk away. Walk away and think about the code, because if you cannot explain in words why you made the change that you did and justify it, then you need to stop and think about it and go back and be able to justify it. So that's part of what's debugging. And I know, your teachers are not trying to torture you when you're asked questions like, here's a piece of code, what's happening? That's 80% of my job, is here's a bug, this is the symptom, what's really going on under the hood here? And so it's really important to be able to read code and assess what is really going on here, because you especially if you go into gameplay or systems, you definitely need this skill, because not everything's going to manifest on the screen, and just saying, hey, it compiles is not a good way to debug. There's a lot of things that compile and are really wrong. So really being able to read code and understand what it's doing helps you be a better code reviewer, and also helps you to write better code. So definitely be aware of what your code is doing, be able to justify what your code is doing, and also write code that makes sense from the way you name things standpoint. If you name things well that explain what it's doing, it's called self-documenting code, and it means that you don't have to put as many comments and documentation in there. And you want to make it simple and clean and easy to go back and make tweaks to and understand what's happening, because it's not just your poor coworkers that have to go back and go, what the heck were they thinking when they wrote this? It's also you 6 months later when you're asked to change the system and you're going, what the heck was I thinking when I wrote this? So debugging, important skill. Really take the time to become good at it. And there's no other solution I can give you than practice. Just experience, practice in assessing the way that code works. And there is no formulaic solution to how to do debugging. It's just critical thinking, and every problem is a little different. I mentioned code reviews a little bit. The key thing that people are looking for when they're looking at your code review is, does it address any deeper issues? Did you understand the deeper issues that are going on? Is your code efficient? Is it handling the problem in an efficient manner? That goes back to your data structures and algorithms, big O, operating. And there are, when you're talking about programming in the industry, there's always a trade-off, just like there was in your fun little data structures class, between memory management and efficiency, and other things that we fight for. There have been cases where I work where I'll write something super efficient that runs super fast in C++, and my coworker will go, that's great, but we actually want to support our add-on community, so it's okay if it runs a little slower because we wrote it in Lua so that the add-on developers could augment it. So you have to also understand what your goal is for your code, because efficiency isn't always king. There could be other goals that are equally vying for that spot, and you have to understand what your company's goals are in order to write the code in a manner that addresses that. Your code should be readable. Again, that's the self-documenting code. If you can't understand what it's doing looking back at it after, walking away, or your coworker can't, you need to think about the names you're using. and again, the maintainability aspect of it. So you're going to learn, spend most of your time reading code as much as you are writing code. You could spend 3 days hunting down a bug, and it's a one-line fix. So it's not a matter of how much code you're writing. It's about writing code well and efficiently and really understanding, and sometimes the most efficient solutions involve deleting 500 lines of code. So don't use that number lines of code thing as a measure. It's not very useful. So now moving a little bit on from what it's like to be a programmer into UI programming specifically. Cross-discipline collaboration is critical. In the games industry, you're working with designers, artists, programmers, producers, managers of all kinds. They all don't speak the same language. It's going to come as a huge shock to you guys working in the game club where you've got artists and programmers together. We don't all speak the same language, if you hadn't noticed. So learning how to speak the language of the other side. If you're a programmer, understanding the artist, because they're using a lot of times the same terms for completely different meanings. So it becomes important to be able to clarify what they mean in their context, what you mean in your context. There could even be differences in context between what, a word like node means to a UI programmer versus a gameplay programmer, depending on the context of the game. So understanding how to communicate across disciplines, even if it's disciplines within programming or if it's disciplines outside of programming, having those communication skills is very important to develop. And the best thing you can do is be respectful for everyone for their role. One of the most fun things about the games industry is you're hired for your role. It's not a corporate ladder. There's not a bunch of hierarchy. Usually you're hired for one of those specific roles like the ones I mentioned earlier. And then you've got a team lead, you've got the department head, and then you got the studio head. So we're not talking about a lot of upward mobility. We're talking about growth within the specific area that you were hired for. And usually growing from associate programmer to senior programmer is a completely independent ladder from the reporting hierarchy. So it gives you an opportunity to really enjoy working and collaborating with diverse people to say, let's make something great, rather than saying, who's the best and how do I move ahead? So that's one of the fun things about the games industry that's a little unique from a lot of other places that I've worked. So that's a little bit on cross-discipline, and yes, being able to speak those two languages is important, and making sure that you're both talking the same language and being on the same page. So UI programming, there's a lot of different aspects of UI that I could speak on. I've picked 4 major ones that I'll touch on. I'll try to get through them all relatively quickly and leave, that looks like, about 15 minutes for questions afterwards. So, layout and design. There's a lot of confusion between a UI programmer and a UI designer. And so I get asked a lot about style, about design and layout questions. And that's totally okay, because as a programmer, I'm not just a code monkey. I do get some input on the stuff I'm building. And I can say to my designer, I don't think that works well, or I don't think that works consistently with our game. So the first thing when you're laying out a design for UI is the style. It doesn't live in isolation. The UI is there to support the main game. So the UI has to have a style that is consistent with the game itself. You don't want, in a first-person horror, to have cartoony, bubbly UIs. That doesn't make any sense. So it has to be consistent with the themes of the game and the style that you're going for and trying to demonstrate in your game. So even within the UI designer's role, he's constrained by what the overall game requires of him or her. So the style gets informed by that. There's also a level of consistency that has to exist. So if I've got a method that the users are used to for navigating through a friends list or something like that, if I choose to create another social list, like I don't know, the characters that I've blacklisted or something like that, it should probably look and feel and behave the same way as the existing screen, because otherwise you're asking them to learn a whole new UI for every screen they go to. So there has to be some level of, I'm in the same game no matter which screen I'm on. So there has to be some consistency both in the style but also in the navigational aspects of the game. There also, that lends itself a lot to what we use code reuse for. As a UI programmer, you try to build as much code reuse as you can. Actually, every programmer does that, but in UI, it's great if you can. We have components that we usually build. This will be the typical thing for a UI programmer, and there's really no standard out there. They've started to come up with some potential tools or something like that, but almost everywhere it's an in-house, homegrown version of what kind of tools you have to work with, and the general tools of the trade are text box, edit box, button, drop-down menu, scrolling list. Those kinds of things all have to be built or be present in your tools library, and if you build it in a reusable way, you can keep using it for every screen and not having to create a new version of that. So if a drop-down box works one particular way in one screen, you want to try to emulate that on additional screens and reuse as much of that code as possible. The other part about code reuse is when you're talking about platforms. So obviously, we ship on the consoles and we ship on the PC. So those are two very, very different ways of interacting with your game. One of them, the PC, you can click anything at any time, no matter what, with your mouse, anywhere on the screen. And you've got a keyboard that can access things at any given time, wherever. So you need to be able to handle that scenario. And so nothing really has any focus. You can kind of put your focus wherever you feel like. Whereas in a console, because you're using just joysticks and buttons to navigate around, something must have focus at all times. So they're fundamentally different concepts. But if you can build the gameplay-ish aspect of that screen in a shared environment that can be used by both platforms and treat each platform like a skin on top of that brain, if you will, then it allows you to reuse things. It also allows you to, if you can create something that separates the thought process of what you're building from the visual display of what you're building, it allows you a lot more adaptability and a lot less throwing out the code that you don't need anymore when the designer comes back every week and changes their mind. As an example, when I worked on XCOM Enemy Unknown, we had about a 2-month process where 1 week we were going to count the number of bullets, the next week infinite bullets, the next week we're going to keep track of the number of bullets, the next week infinite bullets. And this went back and forth, and our wonderful UI artist came up with a new design for the HUD every single time this changed. But if you keep a little bit of something in the code that says, we're going to handle bullets and have a way to deal with either or case, it allows us to pivot and adapt a lot more quickly to the designer's whims. So having a little bit of encapsulation within the pieces of your code allows for reusability and adaptability. That's the one thing that makes UI really different than a lot of other programming departments. Usually the programming departments, they'll report up the chain to your programming department lead, and the department lead is the one who sits in on all of the meetings and discusses what the overarching structure or design is, and then he reports back to each of his departments what they need. UI is very unique in that most of the time we have direct access to the designers because what they're deciding affects the UI so rapidly and is so integrated into it that oftentimes, at least when I was at Firaxis, we had usually direct access to the lead designer a lot because every time his whim of what the design of the game would change, it would have a direct impact on the UI. So that's some of the stuff you can do to try and keep your code reusable as possible. because it will change, the design changes constantly, and you need to be adaptable within your code and not be forced to start from scratch every time the design changes, because it will a lot. And that's just the nature of the industry. Usability as well, like I said before, there has to be a consistency between one screen and another and how you navigate it. But in addition to that, there's also an expectation users have based on other games that have already been shipped. And so there should be some sort of consistency with that, so that the user is kind of already familiar with it. There's less teaching you have to do, less training you have to do on the user if you're consistent with an industry standard. For example, on the gamepad, the industry standard is that B is the back button. If all of a sudden you decided to change it and make A the back button, you get your users really angry at you because it's not what they're used to, and it would make them fight the UI. So you want to create something that is consistent with known standards, with familiar standards, because it makes the game less hard to pick up, and people end up spending less time fighting the UI. The fun thing about UI is it's a very thankless job. Nobody notices good UI. They only notice when it's horrible, and then they complain about it. So it's kind of a thankless job. But the best UIs you'll never notice, because you'll be playing the game and not the UI. If you find yourself playing the UI, then the UI design and programmers have failed somewhere along the way. So, I spoke a little bit more about the platforms. The other pieces of the platform, obviously, that comes up these days is mobile. Mobile is a completely different animal when it comes to layout and space and everything. Again, having an encapsulated shared logic that is separate from the display makes that a lot easier, but you are going to have to write a new skin for every type of platform you're encountering, which is kind of what gives UI double the work of everybody else. For a gameplay engineer, the gameplay is the gameplay is the gameplay, no matter whether you're on a console or a mobile or a gamepad or something like that. Whereas the hi, this is my cat. Whereas UI, we need a custom UI screen for every different type of platform. So there's kind of double the work every time something comes out. That's fun. Or triple, depending on how many different types of things we're shipping on. And that leads a little bit into, I won't talk about it much, but aspect ratios. When you're working on a keyboard, obviously when you're working on a TV, aspect ratio on a TV is pretty similar. So that's not as much of a concern, but on the PC, mostly you can put it in a windowed mode, and then you can drag it around and put it wherever you want. And UI has to deal with the problem of how do we manage the resizing and the weird sizing that we're getting. And there's usually either two answers. One is keep everything a consistent percentage of the screen that it was. So, or it's, it's going to be this number, or you keep it the same number of pixels, and you say, I don't care how big the screen is. My screen takes up this much of the screen, or it's, it's this big, so on a little screen it's going to be, half the screen. And when you make it really big, it just moves over here and gives you more of the 3D view. And when you make it really small, it just starts breaking down. And you kind of say, we're just not going to support an aspect ratio smaller than this amount. The other possibility is to say this is a percentage of the screen and have it dynamically resize, which comes up with all sorts of other fun challenges that you get about word wrapping and distancing, and oh my gosh, now it's aliasing a little bit because it's just that right number of pixels to cause an issue. So PC is a lot of fun to work with. There's a lot of different things that you're encountering. I did talk about code design, sharing between platforms, reuse of existing technology, being flexible and adaptable with design. The one thing I didn't touch on was hierarchical structure of controls. Usually there's going to be some sort of structure built into your tools that you use for programming or whatnot, where there's going to be a parent-child relationship that you're going to have to try to manage with your controls, or at least that would be the ideal, because if I've got a screen here, and it's got a couple of drop-down boxes and a couple of labels on it, I want to be able to move the screen over and have everything else move in relationship to it. So there's usually some sort of hierarchical structure, much like a tree that you guys are used to, that places it in a relation. Again, it can be a percentage of its parent relationship, or it can be a number of pixels off from the position of its parent. But there's a lot of kind of intricate complexities that happen in the hierarchy of UI pieces, and a lot of detailed, fun things dealing with those controls, because like all things in memory management you're trying to reduce the amount of deletion and creation that you're doing, because those are expensive. So something like a scrolling list might have 10 to 12 things on the screen. Maybe it's got 10 you can see and one that's kind of half off the screen on both the top and the bottom. In those kinds of cases, what usually would happen is, as we scroll, as soon as a control goes off the screen, we move it up to the top and populate it with the next thing in the list, so that we're not continually creating. We never have more than those 12 controls, but the data under the hood could be hundreds. So there's a difference in managing what you're showing on the screen versus what the underlying data is attached to that, and kind of managing that in between state. And that's kind of what your control apparatuses, your structures, will do to help you with that. So I've got about 3 minutes left till I open it up for questions. The last little piece that I wanted to touch on, just because I know it's not taught in any of your classes, unless you've listened to me talk at all, is localization. Almost every game today will ship around the world simultaneously when it releases. In order for it to do that, it needs to be what we call localized, which means translated into other languages. This means all the text that you see on the screen is coming out of a database somewhere that we're sending off to someone to translate for us, so that we can show it in French and German and Spanish and Russian and whatever else, Japanese even. So those translation issues are very important in order to get the full markets that we're capable of, because we're obviously going to sell a lot more units if we're selling it across multiple countries and all of that. And all localization things have to pass an ESRB like we have here. They are all called something different in other countries, but basically they have to pass the rules and regulations of that particular country, both visually and culturally, but also, so that it makes sense and it matches their language. Full translation is when you translate both the text and the audio. Partial translation is usually when just the audio gets translated, but they keep the text in English. When you're translating, the things we have to keep in mind are things like singular, plural. Those kinds of, I might have, you just looted X number of items. Well, if you only looted one, it's going to say item, not items. And so you have to have a structure within your localization that handles singular, plural, and it's not just sticking an S on the end of it, because what if you collected mice? Mouse, mice, there's not I put an S on the end of it and it changes. So singular, plural has to be managed within your localization. There has to be we don't have it in English, but plenty of other languages have a masculine and feminine, and it changes from language to language, because, when I was working on Civilization, we had wonders, and it could have been, and I don't remember specifically what it is, you guys who took languages stuff would know, it could be that in French it's La Eiffel Tower, and in Spanish it's El Eiffel Tower. So when it's masculine and when it's feminine completely depends on the language itself. And so we need to be able to manage that, or at least give an opportunity to the translators to manage when things are masculine, when they're feminine. We're also dealing with inserting data into sentences. Again, using a Civilization example, you could have, the French built the Eiffel Tower. Well, in Spanish, that sentence might be, the Eiffel Tower was built by the French. Now it's going to be, the put civilization here, built the put wonder here. And in the other version, wonder and civilization have been swapped. And so your localization system needs to be able to identify which slot is associated with which variable, because the variable ordering can change. So you can't just rely on the order the variables go into the string to determine what the final string is going to look like. And there are a lot of localization libraries that do a lot of this stuff for you. So I think I've hit the question time frame, so I'm just going to go ahead and stop there with my rambling on UI programming and programming in general, and open it up to questions, which I'm hoping that our Presidente will let me know what they are, and I can answer them in turn. All right, let's see. Can I hear him? My Discord mic isn't on right. There we go. Okay. So, I'm opening it up to questions. So, let me know what the first question is.
Okay. First question. As someone who has worked both inside and outside the games industry, do you feel as though there were challenges or obstacles that you had to face because of your gender?
Okay, so the question is, both inside and outside the games industry, were there challenges that I faced because of my gender, i.e. because I'm a girl? I will not, make any bones about it. I am usually the only girl in the room. In almost every place that I've worked, I've been the only girl programmer. At my current company, I am the only girl programmer in the department. That's not to say that there aren't the opportunity for women out there. It's just not super common. But one of the things I will say is, all other things being equal, if you can do the job, if you're good at what you do, if you've got the same problem-solving chops as the guys do, then having that difference and diversity actually has been an advantage for me in applying, because all other things being equal, I add an additional element that they don't have diversity-wise. And there's a strong desire in companies right now to have more diverse opinions and backgrounds and thoughts on things. So in a lot of ways, it's been more of an advantage and a disadvantage. I know people have heard about there being kind of an animosity toward women and a derogatory aspect toward them. What I will say is, I'm not going to say it never happens. No matter where you go, there's going to be a bad apple that's going to be a jerk. But I'd say for every one bad apple who's a jerk, you got 10 others that are like uncles, brothers, and, they're there to have your back, and they're going to defend you tooth and nail. And they're like, we don't mess with our girl programmer. So I would say, don't be discouraged by the fact that you might be the only one. Be encouraged by the fact that most of the guys you work with want to see you succeed. And they actually are very supportive in helping you succeed in that way.
All right, next question. What would you suggest about someone trying to go about getting an internship? I tried looking things up in UMBC Works, our school's internal software, but pretty much nothing comes up, especially for someone who is just getting into their major classes. That would give them the ability to start making a more targeted portfolio.
All right, well, the question we have now is, how would you go about getting internships that are not typically found on your typical career websites that you're going to and looking for in the games industry? And that's a fantastic question. The games industry is a small, it doesn't sound like it from the outside looking in, but it is a small industry. And because of that, what I mean is that most of the companies are not large companies. We're not talking about a Northrop Grumman, a Lockheed Martin, an Amazon that hires hundreds upon hundreds a year and can go to a job fair because they just have so many roles to fill. And they've got an entire team of 20-odd people whose sole purpose in life is to hire more people. We don't have that in the games industry. We maybe have 1, 2, if you've got a relatively large company, 4 people working in HR, and they've got to manage our healthcare plan and people that are having issues internally, as well as hiring people and managing interview schedules and all of that stuff. So if they went to a job fair, then they would get so badly inundated that there would be a standstill. On top of which, from once they get past HR into our lap, there's a lot of overhead in doing an interview. First of all, if you get the opportunity to interview, the first thing you'll get from the programming side is a programmer test. You'll take home a test. They'll give you a certain amount of time to finish it. Basically, it'll be, here's a piece of, a solution, a microcosm of a game or something with a bunch of broken code in it. Make it not broken and add this feature to it and make it more efficient and all that jazz. If you do well enough on that test, and again, when you get that test back, you've got an entire team that has to spend time looking at it. That's a couple hours that we're not spending at work. So we're already investing a lot of time just to look at your application. And then if we like that piece, then you'll come in for an interview. Usually if you get to the interview stage, they like your code, they just want to make sure that you fit with the group. So all of that being said, game companies, they are not going out and recruiting. You have to go seek them out. So if there's a company you're interested in, regardless of whether they've got a position that you kind of fit or not, go ahead and throw in a resume or an application. Say, hey, this is where I'm at and what I'm looking at. This is what I've learned, and throw that resume and say, let me know if you have any opportunities. It's kind of you don't want to be pestering, but it's kind of make sure that you're known about. And this is also why networking is important, because game companies will go months and months and months not needing anybody, and then all of a sudden we'll get green-lighted on a new project, and they'll be like, we need 10 people yesterday. Who do you know that's good? And it's not about nepotism. It's more about the whole interview process is arduous. And if we can get a personal recommendation, it certainly helps and goes a long way to helping us. And probably 90% of jobs that are out there never get posted on a job board before they get filled. So making sure if there's a place you're particularly interested, that they're aware that you're there. I mean, don't send them a resume more than about once every 6 months when you've got something new on it to share. But just say, hey, I'm interested, I'm looking, and that's why you go to these networking events, you connect with these people, networking is about creating relationships. And if you've created these relationships, then when something comes up, they might say, well, I haven't worked with this person directly, but they seem pretty excited about the industry, and I've been seeing their resume grow over time. Maybe we should consider looking at this guy and checking them out and seeing about hiring them. So it's harder than these large companies. You have to do a lot of your own legwork to kind of give yourself that foot in the door. But what I say is it's who you know that helps you get that foot in the door. It's what you know that helps you stay there. So there is a lot more on you. So if there's a company you're interested in, go out, look for it. And those who are intimidated by that laundry list of things they require for their next candidate that they put up on their resume, that's their wish list item. They have to pick from the candidates they get, not the ideal candidate that they put on their website. So if you've got, even a third of the things that they want from you, go ahead and apply. Nothing else, you might get an opportunity to interview and get some practice doing that kind of thing. So it's not a great answer, but hopefully that gives you a little more insight on how to reach out. And it's not anything that you're necessarily doing wrong. It's just that that's not where you're going to find the games companies. They're not going to be on those websites because they just don't have the resources to sift through that kind of information.
Okay, another question. Have you ever had to deal with the aspect ratios of one of those extremely wide Samsung monitors, the gamer monitors?
So I know that my coworkers have had to play with that a little bit. A lot of times we just kind of, if everything's anchored, a lot of times we use anchoring. So if we are not resizing our screens, but we're just saying this is the max pixel it is, once you get huge and longer than that, then just anchor it over to this point and don't make it any larger, and they can see more of the background screen. Now the graphics guys, they're the one that make sure you see all the background no matter how wide it is. But usually we'll just use anchoring. We'll say where it is pixel-wise or percentage-wise is based on how far away it is from this edge or from this parent's edge, whether it's the top, the bottom, left, right, whatnot. So we're using usually some sort of an anchoring mentality in order to move the pieces around. But as far as the underlying, like, how the whole visual reacts to that, that's more of the graphics programmer side.
Okay. What sorts of qualifications are larger companies like Firaxis or ZeniMax looking for? I often see 3+ years of experience as a requirement, but how strict are they about things like this?
Again, that goes to what I was saying about hunting down the internships. That's a wish list item to have the 3 years experience. If they can get somebody with experience, wonderful. If they can, if all they get is a bunch of college graduates and they can find one that really knows their stuff, then that's waivable. So don't be deterred from applying just because one of the aspects of the job description is something you don't acquire. Again, they have to pick from the applications they get, not from the ideal candidate that they threw out there as their wish list item. So, yeah, I'd say just don't worry about that aspect of it. Go for it. Ask them, hey, if you get a little bit of a response and they said, sorry, not at this time, you can ask, what do you want me to do? What are you looking for that I can prove upon? It's more about building your skill set, hence the whole programmer test and all of that, than what your GPA is or how many years or whatnot. Quality over quantity is always going to be taken in the industry.
Okay, and I think we've got one last question.
All right. One last question.
My monitor suddenly dimmed out. Are there issues with royalties on games like Lord of the Rings?
Are there issues with royalties in Lord of the Rings? Not so much royalties as trademark. And yes, trademark's very important. The only reason I got to work on a Lord of the Rings game with the actual film footage was because EA had acquired the rights to the game. And if you don't have those rights, you can't use those visuals. In fact, I've actually been scolded, or not me, but other people in our company. Programmers like to be a little funny, and they'll, go, I need a temporary icon here. Let me just put a little logo of Batman or something on there, and someone higher up will be like, oh my gosh, you gotta remove that immediately because it might possibly ship, and then we'll get sued. Because we don't have the rights to that icon. So it's very important that you have the ability to use the trademarks that you're using. Otherwise, your company could get sued for using them. So anything like a proprietary thing like Lord of the Rings, you absolutely need to have the trademark from the owner of that IP. IP is huge in this industry. This is why generally we don't have I have a great game idea, I'm going to make I'm going to make hundreds of millions of dollars because I have a great idea. Everybody's got great ideas. The key is to work with people in a collaborative environment to bring to fruition an idea that is being funded. So whoever has the money gets to pick the idea. Whether that idea is backed by some sort of IP or is what we call a new IP. And a lot of companies will seek to create a new IP because then they own it. And then they can continue to build upon that IP. And it's a lot cheaper than constantly buying an IP from somebody else or borrowing that IP and being subject to the whims of the owner of that IP. Which IP is intellectual property, for those of you who didn't know. And yes, it is a big deal in the industry. I know that Take-Two, who owns Firaxis, at some point when I was there, ended up suing some crazy Japanese or Chinese company that was creating and marketing a game that looked almost identical to Civ, but wasn't Civ, but used a lot of the same artwork. In the same way, proprietary technology is also very important. This is why for programmers we use programmer tests, because you can't take the code that you built in one environment and then go show it to another company and say, hey, look, this is what I did. No, the other company owns it even though you wrote it. So you can't take it with you in the same way that artists might be able to take some renderings that they did given the permission. So you have the programmer test becomes your portfolio once you've been working full time, because everything is owned by the original company. And if you take that with you, since you were being paid to build it, then you can get in trouble. There was an issue with ZeniMax with that as well, when the person who helped build a lot of 3D work left and took a lot of that technology and built Oculus. You can go look up that somewhere else. I'm not going to say anything more about that other than what's up there publicly, but just to say that when you build something for another company, they own it, you don't. So it is proprietary to that company, whether it's IP or whether it's technology. So hopefully that answers that question, and I think I've gone past my time, and it's time to let the other speakers get going. So hopefully that addressed some of your questions. I should be around at the lunch session. If you all have any more questions or want to chat a little bit more, I'll be having to hit the road after lunch, but I will be around for the lunch session for additional questions. Thank you for the opportunity, and I'll let you guys take it away from here.
All right. Hopefully my image should be up on the stream right now, if everything's according to plan. Our next speaker is going to be Arthur Gold. Arthur Gold is a UMBC and Game Dev Club alumni and has been working at Firaxis for over 11 years, working on the Civilization franchise.
Alright, I'm going to step away and get myself some lunch.
His favorite work in game development is anything that straddles the artistic side and engineering side.
1, 2, 3, testing. 1, 2, 3, testing. Can you hear me now? One, two, three. Okay, great. You can hear and see me now. Perfect. Okay, here we go. So my name is Arthur Gould. Unlike Katie, you will not be seeing my face for most of this presentation. I kind of have a little PowerPoint that I put together, which I think will be much more interesting to see than my mug. So this will be a presentation on VFX for games. So who am I? You can see a little bit of my face there. On the
You're good. Okay, great.
Wait. One second. I think I have some audio. Okay. So I am a UMBC alum. I graduated maybe now like 12 years ago. I don't know. It's been a while. I was actually also a member of the Game Developers Club back in the day. I have been working at Firaxis for the last 11 years, working on the Civilization franchise. 1 second, let me just move this over here. I have been working on the Civilization franchise since Civilization 5. Through all of the expansions for Civilization 5, I worked on Beyond Earth, which was kind of a bit of a spin-off with a sci-fi twist. And most recently, I've been working on Civilization 6, along with all of its expansions. So what are VFX, mostly specifically for games? I've done this presentation before, so some of you might have seen some of this footage, but it's a little bit different this year. But there's this really cool video that was put together by a effects artist who worked on Bayonetta, where he put together 2 videos, one showing what what a game would look like without any VFX. But this is the game Bayonetta with like all the character animations, the background, the camera work, kind of everything that is part of the game except for the VFX that's kind of been stripped out. You can kind of get an idea of what exactly the VFX component of a game is. So here is not exactly the same footage, but kind of the same situation in the game with the VFX layers added on. You can see, you know, the bullets, the cheat shooting, the portals, energy portals, the mist in the background. There's also some post-processing to kind of get this like temporal slowdown effect. So it's kind of like all that the extra stuff that shows up. So VFX is essentially a techniques that are used to represent things in games that aren't easy to show using traditional 3D modeling, traditional animation. So it's kind of like all those things that tend to be more like representations of sorry, audio was loud. Representations of releases of energy, right? So like normally things like explosions, fire, chemical reactions, things like fluids, right? Like water splashes, waves, chemicals kind of spilling around, large-scale destruction of things like, you know, buildings crashing down or characters blowing through walls, big puffs of dust that will fall from that. Dramatic weather conditions are generally handled with VFX, so things like snowstorms, rain, thunderstorms, big clouds. Of course, magical effects, as we saw in the Bayonetta video, kind of any sort of supernatural kind of displays of energy. Another big component of VFX is to show status effects and like the gameplay state of the game that you're seeing. So here's a fun little screenshot of Pokemon. And the character on the right, the Cascoon, has been poisoned, right? And like maybe there's UI elements to explain to you that this character is poisoned, kind of touching on what Katie was talking before. But sometimes in the games that's displayed using VFX or some sort of, you know, kind of other visualization method for how do you display that information, whether a character has been mentally controlled or the character is slowed down or the character is got extra attack bonuses, or he's got elemental powers, those kind of things. And the last one that's also kind of a big deal is kind of adding that layer of juice and player feedback to the game, right? This is an example of Candy Crush, which was kind of known for having a lot of good player feedback, despite, you know, your opinions on whether the game was good or not. It was kind of cool to see your actions, right? Because it had fun little animations and fun little VFX kind of popping out whenever you filled in, you know, whenever you got the correct color combination of candies. So one thing to keep in mind is that a lot of VFX work that is done, for example, in like movies or commercials or TV or things like that, is generally handled with offline renderings, which can take many hours to like process a large scene, you know, where like waves are crashing down on a building or large buildings are collapsing and coming down. But For video games, we only get 0.0167 seconds, which is, assuming 60 frames per second, we get 1/60th of a second. This little GIF here, I don't know if it's coming through. It's not exactly 1/60th of a second, but you can see a little flash kind of come by and pop away instantaneously. So we don't get too much time in a game. There's also like a whole game that has to be happening along with all the simulations that you're doing. So what do? We cheat, right? We come up with ways of making cool looking things on the cheap. So how do you make VFX for games? There's a lot of different techniques that are used, but the main technique that is used, the bread and butter of a VFX artist and a VFX system in almost any engine, whether it's 3D, 2D, is particles. So particles and particle systems are essentially some sort of system in the engine that you're working in that is able to display either in 3D, kind of these like cards in 3D space, these like sprites, and in 2D they would just be sprites that are displayed, and that they have some sort of procedural control over them that is kind of going to be handled by the VFX artist. So you would be able to control things like the position, the velocity, what they look like, are they rotating, are they spinning. The benefit is that these systems are efficient to draw, and if you can kind of use simulations that are not necessarily correct physics, but physics-like simulations that you can run on your CPU or GPU really quickly. So this example here is kind of showing a bunch of these little cards kind of popping in and out. For a lot of 3D systems, what you actually want is, you don't want to see, let me go back, you want to see the cards kind of like as they are in the world. You actually want to see them aligned to the camera. So the system will proceed, the code inside the engine will kind of try its best to line up these sprites to the camera no matter where they are in space, to kind of give a feel that they're kind of representing more of a volume rather than the actual individual kind of sprites. Here's kind of the next step, right? You would put some kind of sprite texture, kind of an image on these squares, on these quads. And again, as I mentioned, the next step is to kind of start changing properties on these squares, right? So these particles here that you can see are kind of changing from kind of a yellowish color to a darker red color until eventually they disappear. They're also kind of shrinking down as kind of they pop in, and they will shrink down slowly and then vanish. The next step is then to add motion on top of this. So, for example, in this kind of example here, you can see that the individual particles are now kind of like floating up into the air as they are shrinking down, as they are changing color. So we kind of start to layer on different behaviors for these individual particles, and you can start to see, I mean, this is rather still a bit crude, you can start to see that this might start to look something like a fire, right? So then the next step is you start layering multiple particle systems on top of each other. So here, for this example, I've kind of layered on these little teeny tiny spark particles on top of this larger, like, floofy fire looking thing. And so you kind of would want to start adding more and more layers of particle systems to kind of get more complex behavior and try to simulate the different components of the effect that you're going for. So here, this is kind of the jump for like the draw the rest of the owl, right? So here is kind of a slightly more complex effect of a fire, but you can see that it's kind of broken. If you start seeing the particles, you can see that there's kind of this central layer down here at the bottom of the glowing kind of large fire particles, and then there's a layer of smoke particles behind it that are kind of gray and bigger and softer. And there's a lot of these smaller spark little particles that kind of are flowing up and kind of adding the flying embers kind of touch that you might see in something like a campfire or a bonfire or something like that. So again, particles are kind of the main way that a VFX artist will create visual effects. But on top of that, oh wait, no, I have one more slide here. These are just a couple other examples of VFX that are using just particles to kind of do an interesting visual effect. Wherever possible, I'm going to be showing a lot of little GIFs and videos. Wherever possible, I try to credit the person here. You'll see their username and the Twitter handle if I could find one. So here's kind of a little magical spark effect. This one is more little stylized explosions, right? So you can see the layers of particles where there's like little dust puffs. There's trails of particle debris that kind of flies off and has smoke trails behind them. And so you can see that these are kind of built out of a bunch of different layers that kind of cohesively sell the look of the effect. Another technique, kind of the second most popular technique I would say that you would use when making particle or visual effects for games is scrolling textures. So here, this is kind of a mesh, a model in 3D that is kind of a fan of triangles, just a little kind of arc. If you were to take a texture and then kind of scroll it across, you kind of get a certain level of motion on top of that. And then on this next slide here, it kind of shows some examples of like what happens if you take this to the next level, right? So here's an example of this mesh. You can see it's just kind of a flapping series of like a sheet, kind of like those novelty fires that you might see at a store or something that's just like a piece of fabric flapping in the wind. But it has this texture, this kind of fire texture that's scrolling across it to give it kind of that secondary motion to read it, that reads as a fire. And this example on the right, I think, is a little bit more clear. Kind of you can see here on the top, there is a mesh, kind of an animated mesh with a scrolling texture that's going up. And on the right, it's kind of been colorized, it's been masked a little bit. So you can see that it looks a bit more like a fire. And then on the bottom, you can see if you have more complicated meshes that actually kind of represent a motion for in this case, like a little fireball. If you scroll a fireball texture across it, it kind of reads as this like particle flying through the air. And you can start layering those, as in the example on the bottom. This one has like 2 or 3 of those kind of layered on top of each other. And you can start getting some really cool, interesting motion. Shaders. So shaders are kind of another technique that may or may not be available to you as a VFX artist, depending on what engine you're working on, depending on the type of game that you're making, the type of, if it's 2D versus 3D, the capabilities that are going to be available are different. But shaders are essentially code that runs on your graphics card that is able to take 3D geometry that is passed into it, or 2D geometry really, any kind of geometry, and it's able to do calculations on the geometry and then the actual final pixels that are going to be displayed. And you can do all kinds of cool little trickery to sell special effects, right? So in this example here, in this animated GIF, it's kind of broken down a little bit. You can see the kind of the different phases where there's a texture that's kind of scrolling down on these models, and then there is a special shader that is able to use that texture, kind of animate it, and mask out parts of this model based on where the texture is along as the kind of the vertical axis on this character. And then there's like color tinting and all these other extra kind of little touches that are added on top, right? Again, whether shaders are something that a VFX artist would touch manually or if it's actually handled by a graphics programmer that then exposes certain controls to the VFX artist is going to depend completely, again, on the project that you're working on. Distorted meshes. So this kind of goes a little bit with shaders, but is a bit more of a special case where you might have a mesh. Again, I like this example on the left where it kind of shows you the breakdown. But you might have an individual 3D model, and using either like randomized noise or textures, you're able to push the verts of this geometry out, and if you're able to like scroll that information along the model's UVs, then you start getting some really cool, interesting motion, right? So in this case, you can see that these are kind of simulating smoke, large kind of voluminous puffs of smoke using this technique. Another technique that, again, may or may not be available in the engine that you're working in is physics simulations. Physics simulations, there's either runtime, real-time simulation where you actually would define rigid objects that are colliding in real time in the engine, or you might actually bake down a simulation that was done in Maya or Max or Houdini or some other 3D, 2D package, and you would kind of bake that down into some sort of information that the engine is able to process. Sometimes that might just be as like skinned animation, or it might be some other sort of data that the engine is able to process. Every engine kind of handles this differently, and it may not be available always, but being able to understand how to control physics simulations is something that is a useful skill for somebody who does VFX, just because it kind of gives you a better idea of kind of how to control animation in a more procedural way, right? Essentially, you're kind of animating destruction. You could do this by hand keyframing all of these things by hand, or you can use a system that is kind of trying to simulate the physics of the real world, in a simplified way, but you still need to be able to control it in different ways. So you have to be able to set control settings for like how much friction is there between these things. What are the mass settings to see like this? Is this a really heavy object? Is it a really light object? So you need to be able to understand how to control these parameters to get the visual look that you're going for. Another technique which is used, especially if you're going for like a more stylized or pixel art type of VFX, is hand-drawn flipbook animation, right? So this is like traditional 2D animation where each frame of animation was actually drawn by hand, and you're just kind of playing one frame right after the next. So again, this would be useful in a 2D game, 2D focused game. There are some games that kind of do like some mix between 2D and 3D kind of look. So this kind of technique might still be used in a 3D system, as well as you might actually have flipbook animations that are actually played on individual particles to kind of add that secondary motion. And then there's this technique of using actual 3D mesh flipbooks. I think the latest series of Guilty Gear games were kind of I don't know if they were the first ones to do this, but they were the first ones to do this really well. Where they kind of have this mix of like animation smear frames, but also like their effects. Unfortunately, I wasn't able to find a better picture of this. But here on the bottom right, you can see this like smoke flash thing, this like white smoke flash thing was actually modeled out as individual frames. These are actually 3D models with volume that were just made by hand by an artist. And in the game, they just kind of flip visibility of each one of those frames to kind of sell the look that it's actually animating, even though those are individually they're just static models. Here's an example I think that's a little bit clearer to see, a bit of a simpler case. But you can see on the top here, essentially there is this lightning that's just like maybe 10 different lightning 3D models that were just made, and it's kind of spinning, right? But each frame, a different model is visualized, right? So once you actually start seeing that in motion on the section on the bottom, it kind of reads as this electrical current moving along because it kind of has this like quickly shifting shape. Again, this technique is going to be a lot more work intensive because you're kind of modeling out these shapes by hand. But in some cases, it might be really the look that you're going for, and it's definitely a lot more art directable, right? You can get exactly the shapes that you want if you're willing to put in the work to do them. Another technique, and I kind of broke this one apart from particles, is GPU particles. So this is something that is a lot more popularized now. But a couple years ago was not quite there, but I think the hardware that we have these days is finally starting to get to the point where these particles are used more. So GPU particles are essentially particle systems that are running completely on your GPU, which GPUs are really fast at processing a lot of information in parallel, like really fast. So GPU particles are actually particle systems where you're actually able to run millions of particles simulating in some way, right? You have more particles than you actually have pixels on the screen, potentially. Some of the limitations with GPU particles are that, like, if you're using them in a game, they will only be functional if the user has a really high-end GPU that is actually able to run these simulations. And also there are some technical constraints because getting data in and out of the GPU can be tricky. So depending on the use case that you're using these particles for, things like getting proper collision between particles and models in the game can get a little more complicated. Some sort of simulations are just not possible to do on the GPU because it doesn't quite have enough information about the world around it and about other particles because they're all running in parallel. But for certain effects, it's really cool because you can have a lot of particles, especially for effects where there's like a lot of little sparks, like magical sparks kind of flying around. In some cases, you can do fluid simulation-like things just by using a lot of particles. And essentially, most VFX that are actually going to be done in the end are a combination of all of the above, right? So like particles are the bread and butter, but like once you start creating more complex effects, you might actually have an effect that is built out of particles and special shaders and meshes that have scrolling textures and are animated in interesting ways. Maybe some layer of effect of physics simulation if this explodes and has a cool explosion, but then there's some pieces that are flying off in the distance and bumping into the ground and knocking other things over. So essentially VFX is all about layering different techniques to get the look that you're going for. I talked a little bit about techniques that are used in the games today. There's a few techniques that are kind of on the horizon in terms of things that will be available but are not quite there for running in most real-time games. Actual fluid simulations. So this screenshot on the right, or this little animation on the right, is a simulation running in real time in a software package called EmberGen. So a few years ago when I gave this presentation, I had another slide here, which was from, I believe, the Arkham Asylum game, which had some interesting fluid simulations for smoke when the Batmobile's tires would, spin on the concrete. But in the last few years, ever since I gave that presentation, this has gotten significantly better right now. This simulation is kind of running by itself. There's not also a game trying to run alongside it. So I don't think we're quite yet at a point where most games can do physics simulations of this quality. But there are definitely games these days that are out that are doing some level of fluid simulation inside the engine at real time. So it's definitely something that's coming. It's interesting because in this section here about things that are coming, in the last presentation I had GPU particles, which were not quite there at the time, but these days GPU particles are definitely used in a lot of games. So this VFX technology moves fast, and there's always new techniques that are available. There is this technique called vertex animation textures, which is kind of similar to that slide that I had on Guilty Gear, where essentially you are encoding kind of a flipbook animation of 3D geometry into some sort of data that can be used in the engine. So all these little fluid simulations, you can see, it's a little bit hard to follow exactly, but they're actually perfectly looping, right? This little red paint splatter on the left that kind of falls down and slaps on the ground. These are all little looping animations of 1 or 2 seconds that were baked out in an offline package using an actual real fluid simulation. And it's encoded into, in this case, texture data that is able to be used in an engine as long as the engine is set up for it. So you can actually have little simulations that are evaluated using more complex math ahead of time, but then you actually use them in your game without having to do all the math. You just kind of save it out as this little package, and you can then use it in your game. The main issue with these kind of simulations is that they are very memory intensive. And so just one of these animations might be hundreds of megabytes of data to store. And it's, at least traditionally, has been hard data to compress. So unless your game is really effects heavy, this technique is not quite available for most games these days. There's some people who are using it. Uncharted has used some techniques like this. And I'm sure that there's probably a few other games that have done it in the last few years, but I'm not entirely aware of all of them. So how to make good VFX? I kind of showed you a lot of different techniques about this. This is the technology behind making effects. But effects comes to, there's a few different things that you need to keep in mind. One is correct, I have here correct/appealing motion. So this animated GIF here on the left, hopefully it's kind of coming through. You might not exactly know, like it doesn't exactly look like sparks coming off of a fire, but just from the motion alone, even though there's no fire behind it, you can kind of tell that it's supposed to be representing, like, you know, somebody just dropped a big heavy thing on top of a bonfire and all these sparks came flying out. So the individual motion of particles, kind of that animation is something that the human eye is really good at picking out and getting really good at observing how things move in the real world and how to try to get that effect visually into your particle systems is something that is tricky to do, but is kind of key to making good looking particle effects. And I also have here on the right, this one is called the 10 Principles of Motion Design, but it's, if you're familiar with the principles of animation, the 12 principles of animation, it's kind of very similar idea, right? Where you don't want things to move in just like boring, linear, goes from point A to point B. You kind of want to add interesting secondary motion. You want to use more arcs. You want to use kind of ease in, ease out of motion to just kind of make things more visually appealing. Something else to keep in mind when you're doing sort of visual effects is kind of scale. So in this slide here, I have fires, right? But it's fire at 3 different scales, right? On the left is just a little fire pit with some sticks burning. On the right, it looks like some sort of train cargo accident with a big kind of fire going on. And on the right is a giant tire fire with big billowing clouds of smoke. So like, depending on what the visual scale of the effect that you're doing is at, the motions will be different, right? Like what a fire looks like at those different sizes will vary drastically depending on how big something is. And the last big thing that's very important is, are your VFX serving the gameplay, right? So these are some shots from League of Legends, which I would say is probably the best game right now in terms of like properly showing VFX that are representing the gameplay exactly, right? A lot of their explosions and flashes and stuff like will show you exactly what is the area of effect that this character's attack affects, right? There's not going to be as much ambiguity by like, oh, how far does their effect extend? Once their effects are visualized, you can tell exactly how far is this area of effect covering. Am I getting within the range of this attack, right? You don't want VFX to kind of obscure what the gameplay is. You want them to accentuate the gameplay and convey more information to the player that is not conveyed in other ways. So I've kind of touched upon some of these, but the skills that you are going to need, that you would want to have as a VFX person, is again kind of a solid understanding of animation principles and just good observation, being able to observe the world around you. How do things move? How does energy dissipate, right? If there's a fire, if there is a splash of water. If you want to do VFX professionally, you need a solid understanding of particle systems. Right? You need to be able to understand how to get the look that you're going for using a particle system. And one of the big ones is a willingness to explore and learn new techniques and tools. As I was putting this presentation together, it's like there are so many different ways to get the look that you're going for. And being able to explore and research which techniques you need to use, which techniques are available, which techniques are coming in the future that you need to learn, is kind of a skill set in itself, is trying to understand what things are available now, what things will be available, and what's the best techniques to use for this specific look that I'm going for. Some skills that are not critical but are useful are math. The more math that you know about, that you're able to kind of understand, the better off you'll be. And some coding ability is useful for, again, driving shaders or potentially programmable particle systems. So at Firaxis, for example, for the Civilization engine, we've actually, in the last few years, created a programmable particle system that is actually fully programmable with its own little like scripting system. UE4 has the Niagara particle system, which is fully programmable with their like node-based coding system. I have known many VFX people who are not completely familiar with coding. They don't know any coding, they don't know any math, but they're still amazing animators and can do awesome looking effects. And I've also known some of them who are math wizards who can do cool stuff that would be hard to even imagine trying to do things like by hand. So if you want to learn more about VFX, again, go online, look for VFX on the internet. I'm sure that most of you are pretty internet savvy and can find things. There's this website called realtimevfx.com, which is kind of a community of VFX artists. There's forums and, you know, kind of little contests that they do, kind of like, if you're familiar with like Polycount or 3D Total or all, I forget what the popular ones are these days. But it's kind of a community if you want to be able to engage with other VFX artists. Like Katie was mentioning, it's a good place to do like networking if you're interested in pursuing VFX as a career. And again, like try to get your hands on some sort of engine. Again, there's freely available engines like Unity and Unreal that have really solid particle systems that you can get for free and play with to kind of learn. If you have access to Maya, Maya has built-in particle systems which aren't exactly the same kind that you would use in a video game engine, but will give you a feel for how do you control kind of procedural animation using these particle systems. And I think that's all I have for this presentation, and it seems like it's about right on time. So hopefully it all went through, and we'll open it up for questions. Let's see. Not sure if I'm actually hearing any audio from Brandon right now. I don't think so. Hello, Brandon? Can you hear me? Sorry, I apologize for the... yeah, essentially Brandon might be muted.
Okay, there is one question in the stream.
Okay.
A question for VFX. Do you think more of 3D or 2D construction when making VFX?
Okay, so in case it wasn't heard, the question was, do you think more about 2D or 3D construction when you're thinking of VFX? It really depends, right? So it's both, depending on the use case. So I'm a big fan of like traditional animation and like anime and cool hand-drawn animation. And if that fits the style of the game that you're building, then it makes more sense to kind of think about your effect in 2D and how it's going to show up on the screen. But if you're making a 3D game where the camera can potentially move around, right, you have to think about how is your effect going to look like if somebody looks at it from the side. What is it going to look like if people come at it from the back? What if people look at it from the top? So, for example, for the games that I work on, like Civilization, it's mostly like a top-down kind of strategy view, which kind of has its own set of limitations in terms of what the player is able to see. But if you were doing a first-person shooter, right, like the constraints are going to be very different if you're making a fighting game, something like that, right? So it's going to be very different depending on the game that you're building. But again, personally, it just depends on the mood that I'm in at the time, right? Sometimes if I just saw a really cool 2D animated movie, I'm going to be in that mindset for a while. If I played a really cool 3D game that had some nice VFX, then I'm going to be thinking about that, take the inspiration from that. So hopefully that answered that question.
Okay. Looks like my voice is coming through the microphone, so you don't need to read this, but can you ever have too much VFX?
So the question was, can you ever have too much VFX? And I know that's a bit of a tongue-in-cheek question. So I mean, like, the more explosions, the more magical flares, the better, right? I mean, I love a lot of explosions. I just watched the Godzilla versus King Kong last night, which was a giant VFX spectacle. But again, as I was kind of mentioning in one of those slides, the key thing about VFX, at least in games, is are you actually contributing to the gameplay, right? So again, like League of Legends, if there's like 10 characters on the screen all using their ultimate abilities at the same time, it can become really hard to read visually what is even happening in the game, right? So you don't want your VFX to go crazy to the point where the player can't even tell what's going on, right? I mean, at some points that might be fun for a moment, but it could just get really obnoxious and distracting. And of course, the other consideration is performance, right? So depending on the game that you're building and what hardware you expect people to play it on, you are going to be limited by how many effects you can show on the screen, right? If it's something that people are going to be playing on their 2080 Ti video cards, you have a lot more leeway than if they're going to be playing it on a Switch, if they're going to be playing it on their phone, right? So again, it's like with all game development, it's kind of a balance. So, yeah.
Okay, next question. When you try to make games for your closed system audience, are layered particle systems the least intensive on hardware?
So the question was, when making games for low-end machines, are layered particle effects the least intensive on hardware? So the answer to that is a little bit complicated, just because it depends a little bit on the engine. It depends on how things are set up. Particle systems are generally very cheap to simulate. So most particle systems are low performance, and you can run them on low-end hardware. And again, like layering a few of them is usually fine. For certain games, right, like in Civilization, we have a challenge where we don't actually, you might not think there's too many VFX going. But for example, like if every little teeny house that is in your game has a little smokestack on top of it, even if, each smokestack is maybe like 20, 30 particles, if you have hundreds of houses, all with their own little particle systems on top of them, it can start to add up quickly. So generally, yes, layered particle systems are kind of the cheapest solution. But again, like sometimes in an engine like Unreal, you might actually be able to get away with like a shader solution to get something even cheaper, depending on the hardware. And if you're doing like a 2D game or like a pixel art game, then maybe just a simple flipbook animation, just a handful of frames done by hand, can be simpler. But as a rule of thumb, again, particle systems are, the reason they're so popular is because they are cheap to process and to render. But yeah, again, it's always a bit of a back and forth. Again, if you're working in a game professionally, you can discuss it with your graphics engineers, yeah, so it's kind of an exploration thing. You can test things, see what works best, and again, it's going to depend on like how many of them you're showing, and does it actually show what you want the effect to look like using particles. So can you get that look or not?
How did you transition from the art you were doing in your classes at UMBC to doing VFX professionally?
So a lot of it, for me personally, was I started to develop kind of an interest in, so that there's a few aspects of it. Some of it was an interest in like motion graphics. So I started to get an interest in motion graphics and like getting cool abstract motions in the games. I'm just like in visuals in general. And I started to get an interest in procedural animation. But I had no interest in doing like actual character animation. It wasn't something that appealed to me. So I kind of started investigating like, is there kind of a use for those skills? And VFX seemed to kind of fit that bill, right? Where like you're not animating things by hand, even though you can sometimes. You're kind of using procedural systems to create interesting motion, whether it's more abstract or more realistic, depends on the look you're going for. At the time, there were no engines UE4 was not available. Unity was available, and it had a particle system that was not as good as the one that's there now. But I started playing with that to some degree. I started using the particle systems, like I said, in Maya and 3D Studio Max, because I had availability to that software through UMBC. At the time, we were also, as part of the game development club, we were using the Ogre 3D. It's more of a rendering engine than a game engine. But it had some particle systems that you could kind of poke and play with. And there was some other software, I forget exactly what it's called now, but it was a particle system engine that I was able to get a demo of, and just kind of start playing with it. But yeah, I mean, in terms of like, if it's something that seems interesting to you, again, in today's day and age, I would definitely recommend grabbing something like Unreal or Unity, and just start playing with their particle systems. Go online. There's a bunch of tutorials in terms of like how to get started. And then, like find cool effects that you might want to do, and like, try to break it down into components. Like, if I had to do this for a game, like how would I do it, right? So just like start observing games and movies and like try to think about how they might have actually done some of these things. You may be able to answer some of them, you may not. I mean, some of them are complex enough that it might not be clear how they were done. But the more experience you get, you can kind of start, it's kind of like in the Matrix, you start seeing how people, instead of seeing the code, you start to see behind the particles, behind the VFX system, you start to see how people might have actually done it. You can start to tease apart the individual components that they were using. But that just comes with practice. So until then, I would say just like play around with the freely available engines that are out there, and just get as much experience as you can. And again, go on the internet and look up real-time VFX, and you will find a flood of information. So.
All right, and I've got one more question in the chat. This is a question for me personally. Do you ever have to design your effects around how the low-level graphics handler works? Like, do you need to optimize your effects so it can be baked? The textures can be baked. Sorry, batched.
Batched. It depends, but yes. So again, like normally VFX tends to interact more with the VFX team tends to interact more with the engineering team in terms of like how to optimize things, because it's kind of a very fluid type of work. The performance considerations for the work that you're doing might not always be entirely clear. So having an understanding of like how does your engine actually handle some effects might inform how you actually have to author them, right? So if you have a system that is able to batch, if you have 20 VFX that are playing, and in order to batch them all together, all the VFX have to be using the same textures, for example, then that's a limitation that you're going to need to understand in order to author your effects, correctly for the game that you're doing. Sometimes some of this stuff is just handled, transparently for the user. So like the engine will determine itself whether or not it can batch things together and render them as a single draw call, or whether it can't, and you have to go back and like optimize, some of the systems that you're using, some of the particles that you're using. Again, and for example, that gets more complicated when you start doing like custom shaders, right? So for example, in Unreal, if you have, a unique shader for every single visual effect that you're doing, there's going to be performance considerations for that, right? Because you're going to have to upload each one of these shaders into your video card so that it can display properly. And there's no reuse between the different visual effects, right? While you could instead create one shader that might be able to do all these different effects if you just control certain parameters. So long story short, yes, as a VFX artist, you will have to, at least to some degree, understand what the hardware is doing, and what the engine is doing in order to do your best work.
All right, thank you. That was very informative. Looks like we've ran out of time, and right now is going to start our lunch break. So,
cool.
From 1 to 2, we'll have a.
All right. Hopefully everything should be coming in now. Here, I'm gonna exit this. All right. So right now it's going to be our lunch break. We're just going to be on standby for about an hour until 2 o'clock. At 2 o'clock, we're going to have our next speaker, Ryan Griffin, give a presentation on organic environments. So during this lunch break, everyone's going to pretty much be on standby grabbing lunch. We'll have a link to a Discord. Can you see it now? We'll have a link to the Discord where you can chat with some of the presenters. and we'll be back at 2 o'clock. I'll grab the link to the Discord and put in the chat. From our lunch break, we're now going to start our next presentation. This presentation is from Ryan Griffin from Oxide Games. Ryan Griffin is a 3D artist at Oxide, former professor, and UMBC alumni. He's back at it again with another presentation. He presented at last year's DEC in 2020. This year, he will be focusing on organic environments to create a living world. One moment, we're going to switch to Ryan's stream. Last year's DEC in 2020. This year, he will be focusing on organic environments to create a living world. One moment, we're going to switch to Ryan's stream. Last year's DEC in 2020.
Okay, looks like it's going.
This year,
so
he will be
I'll
focusing on
shut that
organic.
down for a second, and I believe I'm good to go.
I'm going to switch to Ryan's stream.
So, all right. So again, hello everyone. My name is Ryan Griffin. I work at Oxide Games. I've been through. I was a UMBC alumni from 2011-ish. I started 3D when I was 15. I am going to be doing a presentation on organic environments. I actually did a presentation last year for the 2020 session. Please check that out. It basically goes over my backgrounds, how I got into games, as well as a presentation on trim sheets. I also did a tutorial on how to take a prop asset from concept to finished in-game asset. And all of that is free for everyone to check out. But this time around, I'm going over organic environments. So, who am I? My name is Ryan Griffin. I'm currently a junior 3D artist at Oxide Games. I used to be a professor at Howard Community College, graphic designer, animator, as well as motion graphics. Someone's okay. Oxide, they made Ashes of the Singularity. It's a strategy 4X kind of game. Currently, we're working on a new project. I can't really talk too much about it. However, my role originally was outsourcing, and I transitioned over to the architecture team. However, I pretty much do. I'm more of a generalist on this project, so I work with several different teams, and this time I'm going over organics. You can check out my portfolio as well as a bunch of my other stuff here. You can look it up at Ryan Griffin at ArtStation or Zero Strike. This is a little bit. This is a little bit of my work here, but I've already kind of gone through this before, showcasing some of my work. This is like one thing that I'm like kind of like got me on the map and helped to get me my job. You can see some of the stuff here for those that haven't seen my work before. So I haven't really done too much that's new. I've been kind of working on several different things, but this is actually one thing that I was working on recently. I've been working on a little bit of organic environments, specifically working with terrain as well as materials. So substance designer work, working on terrain, rocks. Trees, grasses, shrubs, vines, all kinds of stuff like that. So there's a lot of different things which make up a organic environment, and a lot of time it's like a good like 50% of the screen. There's a lot of stuff which goes into organic environments, and it's good to have multiple people working on different aspects of the of the actual environment. And this is one thing that like every game is probably going to need some kind of organic environment. So it's about what kind of components actually go into this to make it actually work. And it does actually depend on what kind of game you are making. So one of my friends, Roy, he's actually much more of a organic environment artist, but he does like stylized stuff. And if we take a look at this right here, like this is the kind of stuff which like screams like, hey, I want to go there and explore because that's a really cool open world environment, right? And he pretty much made like every part of this from the trees, the grass, the building, the character, and one of the cool things about it is that it's all optimized pretty much, which you can see here. Green is good, and red is bad, and white is extremely bad. So optimization is important, especially for a game, and as well as organic environments, because when you make an asset for it, it's probably going to be used all over the place. So like breaking up like what's in this environment, like what kind of makes this environment work, like breaking up environments into parts, because when you have this open world environment, it's kind of like this like living world that like is living and alive, and there's stuff moving, the wind's blowing, the leaves are falling, there's birds, there's deer like going around, there's babbling brooks, there's all kinds of stuff which make up a environment. And it helps with the immersion part of it, and that's the thing that someone needs to help to bring that vision together for that, and it takes a lot of work to make it feel lived in. And you can play with style a lot, whether that is realistic to many different forms of a stylization. And one of the biggest impacts you can do with that is with organics. And just breaking down, okay, like if you were to go like outside, like what would you see? Like it's recreating nature in many different aspects of it, or enhancing it to make it its own thing. Let me pull up this artist here. She's really good at making stylized environments. So this is just a little showcase for her stuff. But like, take a moment to like look at this. Like, what kind of environment stuff do you see? Like, what kind of things like make this environment feel alive, right? So you have like a little bit of like grass and stuff flowing in the winds, you have puffs of smoke, you have leaves and grass coming down, you have wind, you have things that are like animating, but also the visual aesthetic, the styling for the stone and the wood, and the like vines growing up, the ivy, like the door handle, like all of those little things help to make this world feel alive. And if you break it down into each of the components for it, you can really see how like it's not that many assets. It's mostly a matter of bringing everything together for it. Same thing with the actual like ground as well. So here's something that's kind of breaking down how you would do like ground. It's you can like have the different components to it, and say you want to have this field of grass, right? But you want to have like specific little like grass or specific little like tiles of stone and dirt where someone has gone through and like walked and created a new trail, and so someone came around afterwards and continually going along this path, right? It's thinking about those kind of things within the environment and breaking down the different aspects of a environment and a living world. Here's another breakdown for that grass as well. I'll explain what this is a little later, and this is like a full like breakdown from like start to finish on like how to do like all the different components there. You can obviously check out more of her stuff later. So back to here. Okay, so a organic environment, rocks, trees, vines, bushes, shrubs, grass, water, river, waterfalls, oceans, cliffs, valleys, hills, mountains. All of that creates a living world that people want to actually explore and go into. Whether that is open world or whether it's just a small little section for a cinematic, there's a lot of stuff which goes into that, and that can really sell the immersion for the game or your visual aesthetic. So what is a biome? Does anybody know what a biome is? A biome is a collection of plants and animals that have a common characteristic for the environment that they exist in. Can anybody name the type of biome? So there's a lot of different kinds of biomes throughout like our world, and you can each of them have their own characteristic of the plants, the terrain, the animals, the like microcosms of how this rock created a new section and destroyed something and then created something else. Same thing with rainfall. Rainfall and wind will shape how rivers are formed, and where cities are built. All those things are kind of dictated by your geography and the biome which you live in. And there's kind of like different aspects of temperature and precipitation, and you can kind of like go through that. So what type of biome is Maryland? Does anybody know? It is a temperate deciduous forest. So anything with that green, with the Appalachian oaks. So that's most of Maryland. So what's in that biome? So it has different seasons, and in a forest, it has different the tree layer, the shrub layer, the grass. If it has rainfall, or sorry, if it has like rivers, or if it has more of like shrubland into prairie, or a cut field area. There's that transition between forest to grassland to where humans have come in and influenced the actual biome. You also have the animals which live there, which also affect the biome that they live in, which has that different ecosystem, and so put those two things together, and that helps to get your living world. So if you've ever been to like Gunpowder River, the Gunpowder Falls, this is during fall here. You can kind of see what it looks like. Here's almost the exact same thing, but in Assassin's Creed Odyssey. Very, very similar. So same thing here with the Patapsco, like same kind of feel. Like this is a little later from somebody else's portfolio. So right down the street for me is the McKeldin State Park. This was I taken my cousin's dog Callie, which is that's her there. I was taking her to the park there, and I was just like enjoying the summer day like it is right now. So in that, let's break down like what's actually here. If we look at the actual river system here, you have the rocks there, the trees there, um, the uh, the the trees around here are mostly like white oaks. It is a deciduous forest, so it has different types of trees here, but there is predominantly a lot of oaks, and the different stages of grassland as well as the actual like dirt content as well. So if it's more towards the ocean, it's going to have a different type of dirt in comparison to one that's more in in the mountainous side of Maryland. And you'll have different shrub layers as well, depending upon how close they are to the trees, as well as the river as well. So if you look at like everything that's in there, that is your list of things which you have to make to help make that environment feel lived in. So that is kind of the list of things which you need to make. All right. So trees. So with the trees, you kind of want to think about like your list of things to make, like getting at least one type of everything in your list of your must-have stuff. Because when you have all the elements to make your tree, right? So let's just say we're trying to do a pine. So your Christmas tree, basically. You have your trunk, right? You have your branch, and then you have the pine needles, which go off from that. And if you need to have like snow or if it's like a dead branch, those are going to be different components to it. And you want to have some variation with that, and then you would want to be able to have offset going up the tree in terms of its placement for the actual branches going up the tree, as well as the sizing of it, and that's going up in that triangle shape. On the left there is a birch tree with the actual texture sheet on the side there. So like the different steps which you would do to actually make that, you would have your trunk, right, which is going up. You have the transition between the trunk and the root system, and where it actually blends into the actual dirt layer. So that transition is a kind of important if you want to have exposed roots or not. Then you would start to have your branches start to come out, which is when you would do that alternating pattern, going kind of off of that 90-degree with a little bit of a variation with that. But basically, it's a tube running off of it with a collapsed end piece, and then you would kind of fill out the tree. Making sure to look at it from every angle, maybe look at it from far away, and look at the actual silhouette of it, and look at it from all angles to see how it's projecting. And then once you're satisfied with the branch placement, then you want to attach those cones and cylinders onto the actual stem or the trunk of the actual tree. And then bridging that gap like this. You can then create secondary branches by taking one of the actual quads and then extruding that out, and then creating separating out branches that way, and then just closing the ends of those. And that's basically your superstructure for your tree. Then it comes down into, okay, how do I make those branches? So you would probably want to start with your plain leaf, making sure that it's like your nice, healthy, vibrant tree leaf. And you can do slight variations of that with like how much it's decayed, or if it's like flowering, if it's springtime, or if it's in fall, it's going to have a transition from green to yellow to reds, maybe even purples and browns, and then a dead leaf as well. And then you'd want to arrange it in a natural pattern, which is useful for that kind of tree. So again, that kind of goes back to the type of tree. So every type of tree is going to have a little bit different kind of leaf shape. So with the white oaks, it has this like a branching pattern with like a kind of a diamond shape. So then you would kind of arrange that in a branching pattern to create that. And like I would probably do that from the top down and make it flat so that you can control the placement of where it's going to be, like this. And then basically just having different areas where it branches out. Once you're satisfied with the placement from it over top, then you would want to start to like bend it and give it some more form and volume and characteristics with that, to give it some more personality, basically. And yeah, then you would start to arrange those branches on the actual tree. And there is like a couple like tools out there. One being Speed Tree, which is used with the Unreal Engine, but you can also still like totally do these things by hand as well. There's a bunch of tutorials here which I have for making trees, and this is like extra content which like I can actually post in the Discord as well as the chat. So each of these are very useful. Another way to actually make the actual like volume volume of the tree is having a sphere and then just populating it with a bunch of cards, and having it be just this like ball of cards, basically. Now, this technique is actually can be used for both trees and shrubs. But another popular technique for bushes and shrubs is to do it more similar to grass, which is having a flat card and then having it be put in alternating intersecting planes, as well as adding in little like flowers if it's blooming, or the actual like tufts where the seeds are. To start with that, you probably want to do the actual stem, and then having leaves branch out from that, and having that as a flat card, and then being able to clump those together and then arrange it in a spherical pattern. There's a couple of tutorials on making shrubs. Also, same thing with the box method. Ivy is also similar, where it is placed on to the actual building structure, but then it'll grow up vertically or down, depending upon where it's at. But it has the actual like stem part, and then branching leaves in clusters, which will be able to have the vines grow and then have them continue that way. So it's actually a separate object which can be placed onto the building which it's on. Or you can do it as a flat card as well. This is another method to do ivy. Grasses. So it's good to have at least like one style of grass, and then doing maybe one or two variations of that grass to give yourself some variety with it. There's a couple different ways to make it. You can do a high poly and then bake that down. So you would basically do your grass shapes and with the stems and roots and smaller leaves, which are starting out, which are kind of like at the bottom, as well as the tops where the actual seeds are. And you can arrange those in different shapes and stuff like that for like different kinds of like weeds or grass types, and yeah, basically just baking that down. So in this graphic here, one here is in the top left. It is the texture for it, and then you would make your actual geometry and put that texture onto a flat card, and then you would cut it up, and then you would take your cut or a slice tool and then cut out like where the ends of the actual texture is, and then all of the blue space is kind of redundant space which you want to get rid of for optimization, because if you think about it, all of these things are alpha cards, and so when you duplicate this thousands of times, it's going to be a really big performance hike on the actual game. So you want to be able to reduce the amount of alpha space as much as possible to help with optimization. So getting rid of that blue area, and then you have your little elements for the actual grass clumps in part 4. Here's another example of that with the different types of grasses. And then what you would want to do is you would want to arrange those in a pattern with like a crisscrossing and creating those clumps into bigger 3D clumps basically, and then kind of being able to look at it from all sides to be able to have it look good from all angles. And you don't necessarily have to do this high poly method. You can actually do a hand painted method where you would just make the grass within like Photoshop or whatnot, and then just apply the same steps with this here, going through step 1 through 4, and then arranging them into clumps like this, and then having several variations of these final clumps, and then having that as your grass clump 1, 2, 3, 4, and then using those as your final in-game. And like I was saying before, optimization. So if you look at like all this white and red, this is probably not going to fly, because this is like a big performance hike on the actual game. You would want it to be in the like green to red area. Here's a couple more tutorials on how to do that. Rocks. So rocks are another big component of making a living world. It's the superstructure which a lot of things live on with the terrain and help break up the monotonous of a singular texture across the world. And it can really make the location feel much more lively and interesting that way, with having interesting rock structures. And one thing to think about is how the rocks interconnect a little bit, because you can have a lot of individual rocks, but you also have to think about, is this something which you can sculpt one rock, right? But if you look at it from different angles, it kind of looks like a different rock. And so if you make enough rocks unique enough to get reuse out of it, you can make them modular, because you can actually intersect those together to be able to arrange a new formation, but reusing the same 5 assets. So if you take a look at the rocks, in the bottom here you have different sizing for it, but each of these rocks you can probably reuse a lot of times. It's just that they have enough they're similar, but they're unique enough. So how do you make a unique rock and have it be modular enough to reuse across an entire formation? And there's also different types of rock formations as well, and that's like part of the challenge. Is it's good to be able to spend like a fair amount of time with making rocks that are going to hold up, and it's also dependent upon what level of detail you're actually looking at. Is this like something that's going to be like far away? Is this something where you can literally like go right up next to it? And there's also a lot of like level design with this as well. So if you think about a level like this, which is more open world but it has these canyons, right? If you tend to like make it into this like corridor, you can funnel the player into a gorge, right? So that's what this is here, and you can do that within different ways. If you have a trim sheet style cliff face, you can have it be modular on one side or the other, and so you can make these like gorges, and you could have like a river running through this as well. But creating rocks with different levels of details, like starting out with large forms first, making sure that it's unique enough with all sides. Typically, you want to have it be unique on at least 5 sides. So if you turn it, you should be able to distinguishably see 5 unique sides across it. So when you starting out with a box or a cylinder, using typically, like, I like to do a ZBrush method. There's like a lot of different methods for it, but like this is one which is pretty popular, using ZBrush Dynamesh, and then being able to use different kinds of brushes to beat it up and shape it into the forms which you want. So if we look back at this, you can kind of see how there's some edges which are like flat, but also some which are have like cracks and ravines and chipping and more unique forms to it. And different brushes will give you different techniques with that. So if you have your starting out with your move brush, and moving it to get your big forms, which is those 5 unique sides, and then using different trim dynamic and trim smooth brushes to get your edges to be kind of unique from there. Using trim adaptive, trim smooth border, and the orb brushes. The orb brushes are very, very popular for making stylized art. They're from Michael Orb, who is a senior artist at Blizzard. These are free. Definitely check them out. And I believe that they actually have a version of this for Blender as well. And like, again, these brushes, like 175,000 views, and people probably downloaded it just as many times. So these things are very popular. Moving on. So from there, like, once you get your shape and your edges the way you want it, then you're probably going to use clay buildup, dam standard, slash brush, and alpha cracks to be able to get something closer to this, which is it's basically making it look from more of like a turd to an actual rock, which half the time is the challenge of making your rocks feel not like a lump of dirt. It's supposed to look like a piece of earth and stone and marble or what have you. And then once you do one, you do a different one, and you make it into a slightly different shape, but it's still in the same family. And then you make a whole modular rock pack, and then you kind of bash them together, and then you can create your forms. Here's a bunch of tutorials on how to do that, going into much more detail than I'm going to. For the length of this hour. The next part is working on the ground materials, and that's what like some of these are here. These are very popular to be able to use a program called Substance Designer. It basically it's actually kind of a tech art tool a little bit, because it uses nodes with noise and filters to be able to give you different kinds of patterns, essentially, and then it's a tile generator, so it'll work from all different size, and it's also procedural, so you can change the actual sizing on it from a small like 1K texture to a huge 8K texture. It'll just depend on what size you actually need for it. You can do anything from realistic, which is more of Daniel Feiger. He's one of the big names in Substance Designer. He's pretty much done everything under the sun. You can also follow his tutorial series as well with the Substance Designer Fundamentals. I would highly suggest picking those up, or if you can get them for free. But it doesn't necessarily preclude you from doing something that's a little bit more stylized. So 3D Exis, he has a lot of good tutorials for doing more stylized stuff, but it's the same understanding of Substance Designer, but it's using it in a slightly different application. So again, it's working with a different noise parameters like Perlin noise or Voronoi noise, crystal noise, like, and then running it through blend filters and creating height data. And then once you get your height data, then you can create different selections for your normals, your color your color information. It can be as basic as something like this, where you have your height noise going into a normal, which is going into your base material, your base color, and then that's blending into your outputs, which is your color, normal, roughness, metallic. Like, it can be as simple as this, or it can be as complicated as that. It really just depends on the amount of fidelity which you need as compared to this and these. And it can be anywhere in between. And this doesn't necessarily have to be organics. It can also be sci-fi. It can be hard surface as well. It is a very versatile program, and I would definitely suggest people learn it. Let's see here. Terrain blending. So you have your rocks, right? Or if you did like your like a building or something like that, it's the actual like blending between the object and your in-game terrain, and that's called terrain blending. And this is a better example of it. So you can literally like just move it around and be able to affect where the actual blending is with the actual object to the terrain. Another thing to think about is when you have terrain and you have your material which you made in Substance Designer, thinking about how it's tiling in the actual scene, like, because the human eye is very, very good at picking up tiling. And so when you put down your base material, you kind of want to understand what scale the environment is and what size you're authoring your original texture at. So you want to scale it appropriately. Another thing to think about is in terrain, you don't just have one material everywhere like this. You have multiple materials, and depending upon what path you are trying to go, you want to be able to have the actual like blending between different materials. And so a lot of the game engines will have multiple material terrain blending. You could do like just like hand sculpting within the engine, which is another technique if you just want a path going from A to B, or if you need like this one area to be like a little higher to like match. Like you can totally do that by hand within a game engine. Here's a few more tutorials on doing some of the Substance Designer stuff. These are all very useful. Billboarding and LODs. So if you think about how within space, like when you look out into into a game world, you have LODs, which are level of a detail, and the further you go back in space, the lower fidelity it can be, and you can save on performance that way. And a billboard is basically a 2D sprite in 3D, aka billboard. So if you look at like if your camera is over here on the right, and you can actually have different things within space, and so your actual back plate could actually be just a 2D background, which is the same thing here. It's 2D backgrounds which are on different planes, which is creating that parallaxing. Again, a LOD system for trees, grass, and rocks, and what have you. And you can actually get a lot of performance actually with how it's actually shading by averaging the normals of the tree to be able to actually have it render correctly, or you can do it as sprites as well. And those are billboards or imposters, which are basically saving you a lot of performance hike with that. But it'll also like create like a little bit of a parallaxing effect if you just have a bunch of billboards. And so you can look at a real world a in-game example of it here, where you have like a actual tree versus a imposter here. So you could actually take that exact same concept and do mountains with that. That's where Gaia comes in. Gaia and what's it called? The World Machine, there we go, which is basically, again, a node generator system which simulates erosion, basically, and create entire worlds this way. You can do it as your actual terrain geometry, or you can do it as a background plane. So if you think about this, and then you have it within scale, and then doing different background planes like this, just adding in those 3D mountains like this, because you may not be able to actually ever get there, but it's something that will help with the immersion of what's going on and create that parallaxing effect. Here's a few more tutorials on that. I got like 15 minutes left, so I'm going to stop here pretty soon to take questions. So, Megascans. Megascans is a free add-on within the Unreal Engine. Check it out. It's a huge library of organic scanned objects, which you can use through Quixel Megascans. Photogrammetry is one of the big trends which has been happening to create photorealism, which is kind of why like stylized art is kind of always going to be a thing, because a photogrammetry is kind of taking over a lot of like real world stuff. Sky domes, like this is your atmospheres for your skyboxes. This is your atmosphere, cloud systems, fog, sunbeams, cube maps. Like all those help to bring a living world to life. I would definitely check out Anthony. He is over at Naughty Dog with the Uncharted and Last of Us series. He's like the king of like this kind of stuff, and has done a bunch of talks at Nomen about this. So you can check it out. Here's just kind of a breakdown of like how he goes and then creates the Madagascar level. Here's a bunch of GDC talks which he has done on that stuff. So again, wrapping up here, quality is king. Try to have a very specific goal. Like just working in games is not specific enough. Try to have a specific goal, like a environment artist at Naughty Dog. It's going to give you a role, a art style, and a company to shoot for. Just be reminded that you might not get your first choice, and getting that first choice might be difficult, but you can still get there. It's just about getting that foot in the door. Leveling up. Here are some more resources, Shark Mindset, and some extra resources there. Now time for questions. Some more resources, Shark Mindset, and some extra resources there. Now time for questions. Some more resources, Shark Mindset. Okay, looking at the chat here. That's from the last chat. Okay. What made you get into 3D so young? I didn't do anything but video games at 15. So I go into a lot more depth in my previous talk with the DEC 2020, but the synopsis on that is I started when I was 15 because I was one of the first. No, I was the first 3D graduate of the Howard County ARL program, which had a 3D track back in 2006, which was the first in the state that had that track. And from there, it was kind of a class of 5 people. Like now it's like 60 plus. So like it's definitely grown over time, but it's more that I had the opportunity, as well as knowing people within the games within the games industry, because my dad knew Tim Train, who is the ex-CEO of Big Huge Games, who is also a big name around these parts, and within this area, everybody kind of knows other people in terms of it's a small world for the people who do this professionally, especially in this area. Let's see, next question. How much would you recommend designing a tree from scratch versus using tools like SpeedTree? It really just depends on like what you're trying to do, and how much time you have, and how much money you have. Because SpeedTree is not free, but and it's also used within the Unreal Engine, and/or any other add-ons which they have, which I haven't heard about until recently. But with SpeedTree, it kind of is streamlined to do one thing. It's streamlined to do realistic trees. If you wanted to do something that's stylized, or if you wanted to do a specific sculpt for this huge tree that the player is going to like traverse by hand and is going to climb up that tree, you probably want something custom for it. So that's something that it's still good to be able to do trees from scratch, if you want to be able to make something custom for that. Next question. Next question's from Tooley. Is it better to learn realistic or stylized? It really just depends on what your personal style is and what you want to do. Like, it really just depends on the kind of games that you want to make. It is good to be able to have that range in style. Like I feel like I'm probably better in more of a realistic style sense, but I love stylized art. I definitely enjoy both aspects of it, and it's good to have a little bit of flexibility with your first job because you don't necessarily know where you're gonna land, and like you can specialize a little bit more once you get your first job because you're trying to learn the job when you get in, but being able to try both, see which one you try to see which one you like better. Okay. Any more questions? Let me check the other chat just to see. Okay. No, I don't see anything there. Let's see, the YouTube chat. Are there trade-offs worth it on making many unique individualized parts? Will it cause performance issues? So one thing that you want to do is back to your checklist. Checklist, where are you? This is what happens. This is what happens when you have too many slides. You want to have your minimum checklist of like, hey, like this is like the minimum amount of stuff that I want to be able to have in my game to get the level of detail which I want. And from here, like you can probably have like one or two variations of these types of things. Like if you look at trees, like you could add in like your white oak, you could add in like a pine, you can add in a birch, but that's also going to be another type of texture and asset which you need to make. Now you could do 3 different variations of that oak tree, right? Or you could do 1 birch, 1 oak, 1 pine, and it basically just depends on like how much time. But if you have like a minimum spec of like, okay, I need at least these 10 assets, that's going to help you to do slight variations of it, because once you make like one type of grass, right? Let me pull up that grass. So once you have like one clump of grass, right, and that's done, you could take that grass and then make 4 more variations of it because you've already made that one asset. It's a lot easier just to duplicate it and then turn it a little bit, move it here, and then it's new variation. So just having the types of assets is more important. But I would say to think about how much time you have to make your game and what kind of quality level which you're trying to shoot for. Second part of that question, will it cause performance/space issues? The performance issue is really twofold. You have the if you look at part number 3 here with the blue and the red, you have the alpha channel for this. The alpha channel can be a little bit more taxing in terms of the texture, and the amount of geometry that the actual card is using. So if like this like clump is using like 30 triangles, like and you have that one clump, but you've reused it 1,000 times, like, and it's not like efficient, then that efficiency is compounded. So if you put in your effort at the beginning of making the asset is going to help with your performance in the long run. Next question: how does this all work memory-wise? Especially with imposter assets. That's definitely something which is going to be down to what's the total number of assets in the game, how is it stored in memory, what's the texture, format, compression. There's a lot of different variables with trying to make it performance optimized. So definitely check with the architect or the actual like graphics engineer to see what the budget is for certain parts of the game, or if you're trying to establish those, I would probably err on the side of lower versus higher in terms of what the actual game can run. So definitely think about those things when you're trying to make your first set of assets for that. With the imposter assets, those things it'll depend on a little bit on how your imposter is getting captured, or if you're just doing a flat image of it. Because if it's something which is like very very far away in the actual game, and the player will never really see it up close, like you can have it be fairly low in terms of its performance and its visual quality, but if it's something which you have like a little bit more fidelity, or the parallax isn't working, it's better to it does have this like optimization phase, which it can be changed like fairly close until it's like locked in with like we can't really adjust it much before it ships, because like with it's always in flux in terms of performance, look, and optimization. So like that's always a good question. Shane asks, how much training did Oxide provide when they hired you? A little bit of that, well, I'd say some of that was stuff that like I learned on the job, because it was a little bit of learning what my role was, as well as how I could help with my job at Oxide. I've already learned a lot of things, but there was a little bit of refreshing with like, oh, how does like this one thing with rig works, or how what's the best technique to optimize this grass, like things like that to help with the minor the minor parts of like learning the job. I kind of already had a lot of the big workflow understanding from some of my online classes that I took, as well as some of my mentors that I had. And that's actually a good segue for the last section here, talking about mentors. So I know that like a lot of students that have finished at UMBC but haven't gotten their job or their first gig in the games industry, one thing that you can do is mentorships. Here is several different links to help with different kinds of disciplines. One of the big ones which I would probably recommend is the Mentor Coalition. It's run by Joss Lynch, and it can be both like generalist as well as specified, like per program. Like if you needed to do character art, or if you needed to do vehicles, or environments, props. There's like a lot of different opportunities out there, and this is just a few here. I did take a mentorship like 4 years ago, I think, which kind of helped me to really get better, and it also exploded my network as well, because once I was able to learn some more stuff from those mentors, they actually introduced me to a lot of other artists in the industry to learn from as well, who I was able to get critique from and ask questions. So I would definitely invest in your own skills and invest in your own education as well post-college. Okay, so I'm hitting the 3 o'clock mark, so I'm going to close down questions. I will be here for the rest of the conference, so I will be in the Discord chat, so if you want to ask me for a portfolio review, or if you have like additional questions, just let me know. I'm gonna hand it back over to the UMC Club. So thank you all for showing up, as well as the other speakers as well. Thank you for presenting. So I will talk to you guys later, and have.
Okay. Thank you, Ryan.
Oh, okay. Oh, goodness me, I hear myself. Oh, I'm so sorry for the feedback loop that everybody's about to get. Oh, I'm so sorry. Hi. My name is Greg. I'm the Learning Support Manager at Unity, and I am the final talk. Yeah! Thanks so much, everybody, for doing the gauntlet with us, and for being here today. Let's get to it. This is your journey with Unity Learn. I wanted to introduce a little bit on what you can do if you're looking to expand your knowledge while using Unity, either to pick up some additional skills, either through summer courses or through work at your own pace training, how to apply some of these things to your LinkedIn, and that kind of fun stuff. A little bit of the indie perspective on how that you can pivot this knowledge there as well. So hopefully there's something for everybody that we can pick up. So let's jump into it. Who am I, other than the disembodied voice on the video? I joined Unity about a year ago. I've got 10 years of game design experience. I started in New York City working in Flash games at that time. So some of you may know me if we've been in the industry before. Previously, I was at Big Huge Games as their community manager. In 2019, I got to give a talk at this conference, which was pretty great. I'm an indie developer, nights and weekends. I've been working on this game called #Blood. Perhaps you'd seen it at MagFest or Artscape or something like that. I recently became a dad about a year ago, right as quarantine started. So now I'm a dad of twins. It's been pretty great. And I joined Unity, like I said, about a year or just over a year ago. So that's been a fun little ride to wear a bunch of hats in the industry, both on the dev side, on the indie side, and put some of this stuff together. So Unity Learn. Whether you're a beginner or an expert, a professional or a student, we have the resources to help you accomplish your creative goals with Unity. If you're not familiar yet with Unity Learn, it's our official online learning platform. It's got over 750 hours of live and on-demand resources. We've recently made these resources available to the community at no cost, so we hope you can take advantage of them as your learning journey progresses. You can find what you're looking for with short, bite-sized tutorials. You can create a Unity application and have the opportunity to mod and experiment with follow-along projects. Additionally, you could deep dive with specific topics and master an area with a comprehensive course. Sometimes when you're going through your job search, and they'll say like, oh, we want you to have certain experiences. We really want to know that you can work with shader graph or particle effects or different VFX or things like that. Unity Learn is one of those places where you can get that just-in-time knowledge in order to speak more confidently when you're going into the interview and be like, oh yeah, I did this little demo and this is what I learned. So you can have that backup. Your learning profile. With the updated site changes, it now logs all of your process as you complete tutorials and projects. This XP tracking is broken down by categories, so you can see both your progress and search for tutorials by discipline. So if you want to specifically look for art type tutorials, if you want to specifically look for things more on level design, on world building, and those kind of things. We'll cover badges, which appear here on the right later on this talk, but they, like the submission tracking, are part of the new Pathways system. But for now, we'll look at some of the featured tutorials and projects on the Learn platform that you may find really interesting. Code-free beginnings. So for anyone who's ever loved building with Lego bricks, the Lego microgame is the perfect place to start your Unity journey. You can use these creative mods to build projects, create your own custom experiences, all while learning the basics of Unity. If you're in the hub, it's available there. If you follow this URL, you can find a whole bunch of mini games and things like that. But Lego is not the only code-free tutorial. We have tutorials for karting, for platforming, and for first-person shooting microgames. And apparently I've got an image missing, so if you pardon me, I'm going to refresh this real quick and see if I can get that image to show back up. Let's see. I was making some last-minute edits to this, and there we go. Apparently I didn't reload the page. There we go. That's the platforming minigame on the right. So there's a series of these microgames. They are for absolute beginners. If you are just considering yourself a designer and you want to work in specific genres and you don't want to worry about fighting the code, just to say like, hey, look at these modifications I did. I changed the color. I changed the timing. I made the gameplay feel more challenging. I've made it feel more relaxing. If you're looking to build up your portfolios, these are a couple of tutorials you can do and build in an afternoon and add them right to your portfolio. The Learn platform also has tutorials for the latest Unity features. So this is Rollerball. Rollerball is a classic. You've probably gone through it if you've looked at Unity tutorials on the past on YouTube or on our platform. We've recently updated this classic into the new input system. So Unity 2019.1 came out with a new input system which controls multiple avenues of input. So if you've got a gamepad, if you've got a mouse and keyboard, if you're working with Xbox, PlayStation, it's a single system that now runs all the inputs. So now we've now updated the tutorial to work with that. So that's definitely worth checking out. It's very, very introductory and pretty satisfying when you get it working all together. Bolt. A short while ago, Unity announced its acquisition of Bolt, which is a visual scripting asset from the developer Ludic. Now our integration is complete, so we're now happy to announce the next steps in our plans to visual scripting for all Unity creators. So it's included in all Unity plans at no additional cost. We just released this Clive the Cat game to help you learn how to make games using Bolt. So there's no scripting, there's no programming. Use this visual scripting system where you hook up flows and you get everything working that way. Clive the Cat is a Sokoban style game. Clive wants his food dish, but he first must navigate through the maze-like crypt, figure out how to open doors, and find ways to pass around like various obstacles, stuff like that. In the project, you'll develop several visual scripts to add a new level of the Clive the Cat game, and along the way you'll learn intermediate and advanced techniques in visual scripting, including super units, events, and state machines, all things that really you need to make your game work and flow together nicely. The next type of tutorial that exists on our platform are motivational tools and inspirational stories. Design and publish your original game. The Unity USC Games Unlocked course is now available and free. Previously this was a paid course that I remember from a little while back, and I was super excited to see this as a free offering. Lots of people start games, but it's certainly difficult to finish one. This course guides you through the process used by professional game makers to develop your ideas, keep your projects on track, and then deliver a released game. The idea is that it takes you through the entire design process. This isn't a straight tutorial. It doesn't tell you what to do and how to hook up things. It is more of a project overview of like, hey, here's how to do your paper prototyping step. here's what you should be developing your core features. Here's how to prototype. Here's and it takes you through the steps in order to begin and prepare a single project. So if you've got an idea that you're milling around, you've got about 8 weeks to you want to try a single game out and see if you can release a game maybe over the summer. This USC course really might be the way to go and help you use it as milestones on your development. Another course that we have is the case study for the first tree. This case study focuses on one of the top grossing Made with Unity games developed in its entirety by a single person, David Welly. After this project, you'll be aware of making use of the asset store, collaborating with others, developing an aesthetic, and managing your time and motivation, especially as a solo developer. So I certainly suggest this is a pretty uplifting course, good way to like view the world as a solo dev. It is tremendously difficult to make a game by yourself, but he's got a couple of tips in this course that really sort of break it down and in a manageable way to think about solo development. These are all the on-demand courses that are available on the Learn platform right now. We also do a series of live videos and live offerings. So we update this on a regular basis, so I do suggest that you check it out. We've got a couple of up-and-coming series. We have got Unity for Animation, the Road to Real-Time live series, which you see on the left. This is a monthly series. Every month they'll be taking another step through the 3D development of this series. So they will go from pre-visualization to a fully complete 3D animated film. Because Unity is for more than games. I know that we're game focused and thinking about that right now, but Unity is also used for industrial design. It's used for VR, for AR, for medical purposes, for mobile, for desktop, and for film. So you can certainly build animated films if that's a route that you're thinking about taking your entertainment gaming career. On the right, we have Create with Code Live. This is a series that we've run a couple of times. It's a twice-a-week series. It begins May 17th. It runs twice a week for 4 weeks. This is for people that are being introduced to C# scripting. And at the end, we have a whole game jam, and you build a game from scratch and then share it off with the rest of the community, with their Unity learners and things like that. So I mentioned badging before. Badging fits into Pathways, which is one of our really big initiatives right now on the Learn platform. You can gain the Unity skills you need to advance your goals and bring your vision to life with your specific career pathways. Pathways are the newest addition to Unity Learn, and they're meant to be long-term study sessions that you can get you ready for any challenge in Unity. They're used for skill review. They're good for prepping for your next job, for your next interview, and there's even a way to include your completion of these pathways on your resume and on your LinkedIn, and we'll discuss that in just a minute. There's currently 2 official pathways. There's one sub-pathway as well, and we'll be working on more in the future. There's one for Unity Essentials, which is a 2-week pathway. It's a 2-week experience to complete, start to finish. And about 14 weeks is the Junior Programmer pathway. That's much more intensive. That covers the whole Create with Code series that I just spoke about, and then goes into more deep dive about refactoring your code, making sure you've got things that are running smoothly. It's really focused on the programmer aspect of finding a job and getting yourself career ready. So as you go through the pathways, in addition to taking on specific topics and learning specific things about your discipline or about working with Unity, it actually sets you up really nicely to develop your portfolio, to work on your resume and things like that. On the left here it says 44 skills. These are the skills the Learn platform automatically organizes and lists out all the skills that you learn along the way. So if you have taken any of our tutorials before, or if you've even studied these things in school and stuff like that, or if you don't, if you know that you've got these skill sets and you just want to come to the Learn platform and see what kind of skills, the way that we list our skills, you're certainly welcome to use those descriptions on your resume to say like, oh, I've done some source control. What kind of words do they use to discuss the way that source control can be written on a resume? Because resume writing can sometimes be really daunting and really overwhelming. So if you look down here, I've got the scene building essentials part listed open. So you can say, you can talk about creating and manipulating game objects. You can talk about implementing base physics. You can talk about working with components and scripts and things like that. It's a much more elegant way to build out your resume rather than be like, I did stuff, I made a game, shrug emoji, you know? So on the right, under the top picture there says licenses and certifications. This is the Unity Essentials Pathway badge, and this appears on my LinkedIn. I actually have both badges now listed on my LinkedIn. When you complete the entire course, we have a partner program that allows you to go to their website, confirm that it's you, link your LinkedIn profile to your Unity Learn profile, and then add a badge. So when you go to apply for a job, they can say like, okay, they know the essentials of Unity, and they know a little bit about junior programming. Okay, so we can discuss with them maybe the command programming. We can discuss a little bit about C#, about using loops, about you've got that foundational information there that you can discuss with a future hiring director. I see a question in the chat. How do you see game developers transitioning experience with Unity Learn into an event like a game jam? That's a great question, and just a couple slides from now we'll call that out specifically. But great question. The last thing that I wanted to call out before we move away from this slide in the pathways is as you go along and unlock different tutorials, you'll wind up also getting free assets that you can use in your future games. So there's prototyping for 2D, prototyping for 3D. There are 3D environments that you can use and things like that. So as you continue to learn, you can just fill out your asset lists as well with prototyping assets to get you up and running even faster. I mentioned that there are two pathways: Unity Essentials and Junior Programmer. So the Unity Essentials is designed for anyone new to Unity. This guided learning journey is your first step towards gaining the background, context, and skills you need to confidently create with the Unity editor and bring your vision to life. Experience hand-on learning as you discover what's possible with Unity. You unlock free assets to support your creating your best projects. Complete this pathway will equip you with the foundation you need in order to further your learning journey and specialize in areas of interest. The Junior Programmer is a much more robust course. Like we said, it takes about 2 weeks for the Unity Essentials and about 12 weeks for the Junior Programmer. Designed for anyone interested in learning to code or obtaining an entry-level Unity role, this pathway assumes a basic knowledge of Unity, has no math prerequisites either. Junior Programmer prepares you to get Unity certified so you can demonstrate your job readiness to employers. This pathway covers topics in programming basics, programming simple functionality, programming systems and architecture, and version control and optimization, all things that you'll wind up using on the job. As was called out before, there's often not a lot of on-the-job training. You've got a lot of on-the-job experience, but the more that you can bring to the table to your future employer to say like, hey, I know the pipeline. I know how to take an art asset and turn it into a game object and hook up components to it. I know how to do a get pull and make my edits and then push back into get. So the more that you're familiar with these things, the more that you've practiced, the more that you can highlight them, the better that you'll rise in that job application stack. And you can work at your own pace with either of these. We did mention that it's a number of weeks long, but you don't have to go through an order. So if you find a particularly interesting topic, such as optimizing scripts one, you can sort of go through. In the screenshot here, it's even got a green progress bar where it jumped a section, so that way we can say, all right, you've completed the first little bit. If you want to just step away and then come back, or if you've already done something else, you can chart your progress there. Is there a time when there will be other courses that won't be just programmer focused? Says Mir in the chat. Yes, we are looking at expanding our offerings right now. In fact, we have a quality assurance QA pathway, which is also on the Learn platform. So I know that we've talked about QA a little bit in some of the previous sessions. So you can learn the skills, including C# basics, how to analyze code, and things like that. So yes, this is one of the unofficial pathways. It's still on the site listed as a pathway. It's built a little differently. This was our first shot at how to build pathways, and the other ones are much more of our model on how we're going to go building forward. But we do have plans for future in 2021 to announce new pathways. I just am not able to. That whole NDA thing that was talked about just recently too. I don't have the ability to announce what they are yet. But keep checking with the site, and we'll announce them very, very soon. So tips beyond Unity. So even if you're not a Unity developer, there are tutorials on the site that can be valuable to your learning journey. This one is called Growing Your Mobile Game. This is engine agnostic. It's an introduction to monetizing your free-to-play mobile game. So you don't need any previous experience in monetization or user acquisition. And when you go through the course, you'll learn about fundamentals of monetization, user acquisition, like we said. You'll be able to identify the key components of effective monetization. It will review real-world case studies and identify your steps along your monetization journey. So that kind of stuff is like, if you look at this image on the right, where you've seen the ads of like, oh, how do they beat this ad? Like, why does that ad work? What networks do you get that ad on? Like, who you should be putting in front of? Like, how to monetize off of that? What the process is when someone clicks through that ad, and where do they wind up, and how do they get to be playing your game? And this again is engine agnostic, so it doesn't matter if you're working in Cocos 2D. It doesn't matter if you're working in Unity or Unreal. If you're building a mobile application, or any free-to-play application, I should say, even if you're releasing a free-to-play Steam game, there may be tricks here that you might want to think about how to grow your game like that. Are assets, pardon me, I'm going to jump back to the chat here real quick. Are the assets completely royalty free? It depends. Mostly yes, but it largely depends on the course. The assets that are for Create with Code are not there for educational purposes only. The other assets that you unlock, yes, you can use in your commercial games. You'll need to read the EULA, the End License User Agreement that appears on the Unity Asset Store for each and every asset. But by and large, if you see an asset on the Unity Asset Store, it's free for you to. You are able to use it in commercial products, but they specifically will call it out if it's got certain licensing agreements. For example, there's also like a model from the short film The Heretic, and that's on there as an example piece. There are other pieces that are for educational purposes only. But by and large, stuff on the asset store you can use no problem on your commercial game. So additional tips beyond Unity, and we talked about Games Jam just a moment ago. The Create with Code Game Jam is a course. Now, originally it was released for the Create with Code Game Jam that we did in the fall, and we're going to do another Create with Code Game Jam here as we finish our Create with Code live series in June. But this project contains all the resources you need to have a successful game jam. So you'll learn about game jams, how to collaborate with others, how to use it as a portfolio piece, and things like that. It's been really great. I got to work on this a little bit, giving some suggestions. That first shot of me at Big Huge Games was actually from the Global Game Jam, which I had the joy of helping to run there for 2-3 years in a row, something like that. So a lot of the tips that I learned while hosting a global game jam sort of helped the rest of the team. This was a larger team effort to create this tutorial, but it was great to sort of work with them and then make it really a group effort to have a lot of combined knowledge going into resources for you for your game jam. So if you've done a game jam before, if you haven't done one yet, this might be a really great thing to check out. So I know that there are some people that are thinking about the indie route of like, cool, I'm an independent developer. Greg, you mentioned that you do, nights and weekends in indie dev. Like, how do you do this? How do you transition into indie dev work? This is the first-person shooter creator kit in the screenshots here. This bite-sized kit has magically miniaturized you, the doctor, into a tiny sickness-fighting force for good. Your mission is to travel through your patient's body, destroying evil germs wherever you find them. I built a short game on my itch page. That's my dog. I don't even know if you can hear it, but So I built a short game with this. I'm hosted on my itch page, specifically calling out like, hey, here's an example in level design, and here's an example in game design and balance. That rifle that's in the first screenshot comes from a completely different game, so I modded that by putting that in. The rifle on the right has been totally reskinned and has a different rate of fire and does different damage types. The image on the bottom left is a vertical drop as you begin the level, so as an exercise in level design, I wanted to work with verticality and make sure that the game itself seemed interesting. So this was a great, as from the indie perspective, I didn't have to search through the store. I didn't have to make all these models. It was a great bunch of essentially tools that I could put together and then show off and be like, here's an example of what I can do with level design. And here's an example of what I can do with game balance and things like that. So if you are thinking about being a game designer or design track and you're looking for a way to add something to your portfolio, this was essentially no code. I did some minor modifications, but you can do it with no code and still have a portfolio piece to say, like, look at the design focus that I did based on the scale of the monsters and how many hit points they have, and that all of that combat balance is its own speciality. Level design is its own speciality. So this single project gave me so much fodder to discuss. So, as I pointed out at the top of this talk, I became a parent about a year ago, and my daily setup often looks like this. And this is about as close to my PlayStation as I've been in months. And we are still in the throes of a pandemic. And I'm really not trying to shout at you. I'm not trying to say like, oh, you'll miss the boat if you don't start right now. Perhaps this is the time for you to start with Unity Learn. Perhaps it's not. That's totally fine. This is an at your own pace thing. I'm not trying to preach to you. I'm not trying to force you. Like, if this is not your tool, that's cool too. Like I said, there might be things that you can get out of it if you do want to focus on Unreal or focus on some other stuff. And I do want to leave you with a few more comments from me personally on how to think about a pandemic and how to handle things, or how I've been handling things and stuff like that. Because I thought this has been pretty fascinating about games being a bigger role, about how people are playing more games during the pandemic. And I know that we're almost clear. I know that people have been able to get vaccinated and we'll be able to see people and stuff. But I hope that means that we'll just be able to have more conventions and more chances to show people our games in real life and that kind of stuff. But I think incremental progress is still fine too. At the top of the talk, one of the other things I said was that I crossed a threshold of working 10 years in this industry, which I was super stoked about. I didn't intend to make gaming my career. So some of you on this call are much more intentional about making a career, about knowing where you are and what you're doing. My degree is in writing with a minor in criminal justice. And I fell into this role and I fell into this industry. And when I got started, I got a really fascinating piece of advice because I felt so far behind. I was like, all right, I'm already 25. There have been people that have been doing this job before. I'm trying to figure out what game design is. I'm trying to figure out how I did some programming classes in college, but how does that help? One of the fascinating pieces of advice I got was to play games, and I know that sounds dumb, and I know that sounds terribly intuitive of yeah, of course, just play games and that'll make you a better developer. You need to play them a couple things. You need to play them intentionally. You need to think about the experience as you go through and as you play, and then you need to really take time and reflect on what you learn. We're only going to make a finite number of games in our career. As you're at a studio, you're only going to, I was at Big Huge Games for basically 4 years at Big Huge Games, and I worked on 2 games there. I worked on Dominations, and I worked on Arcane Showdown. 2 games in 4 years. So if you extrapolate that out, you're only working on 20 games your whole career. You've got more than that. You can have more ideas than that in a single afternoon on all the games you want to make in your whole career. So, in order to overcome all of those pitfalls and really make the most out of the time that you have on the games that you're able to build. If you play other games, you can watch their pitfalls. You can say, oh, this system I really like and I want to try to incorporate in future things, and this other system I really don't like, and maybe we'll shy away from using that. This didn't work at all. So play games, learn from other people's perspectives, and then come back and put it into the work that you do. So as an example, real quick, we're gonna play a game together. All right. So I hope everybody's ready. We're gonna play a game on the count of 3. Ready? 1, 2, 3. This is the chicken game. 1, 2, 3, go. Chicken game. Don't look at the chicken. Game over. All right. If you looked at the chicken, game over. That's it. So this is awesome. I love this. So if you are keeping a track of mechanics, this is great, because to me, if you told me that there was a whole game built out of a single frame or a single image, I would have never believed you. But that's it. There's no way to win the chicken game. That's fine, So maybe that's what you walk away with. Maybe your understanding is having a game that you can't win is frustrating or bad. Maybe having a game that you can't win is a good vehicle for comedy if you want to make a comedy game or something like that. There are lessons that you can learn by every game that you played. I kept a list. I don't know why I kept a list, but because I got that piece of advice, I guess I kept a list. And this year, to celebrate my 10-year anniversary, I've started to use the hashtag the joy of game design, and I've posted daily on Twitter. So if you follow @_tinheart, you can find one game per day for a different single tip. The only way to win the chicken game is to not play the chicken game. Yes, exactly right. MN Chino. Yeah. It is very much the wargaming tic-tac-toe game. So yeah, but hopefully that short example means that you can learn something from that game. And every game that you maybe think about, like, what did you like about the games that you liked? That is always harder to say, like, oh, I liked this game because it was real good. Okay, you are more intelligent than that. You can express it properly. You can say, oh, I liked the way that they hid the hidden achievements, or I liked the way that the health system worked. I liked the balancing of the combat mechanics. I liked the visual art style. There's a lot of things about a lot of games that you can really like, and hopefully put into your craft and make better games, because you only get to make a finite number of them in your career. We talked about game jams before, and I'm going to hark on it again. I had a chance to. I haven't done a lot of game jams this year because being a parent, my time has been finite. But I got to run one, so that was really cool. I got to run the Boat Jam earlier this year as an independent dev. The Boat Jam is an acronym. It's BOAT, Better Optimization and Testing. The idea is that you spend a weekend working on a game that you'd previously done for a jam that you really maybe put an extra 48 hours on. When you finish a game jam, you frequently say, like, all right, that's it, I did it, and you put it on the shelf, and you're like, yeah, but what if we added sound? Or what if we put in that second level that we never really got to put into, but we discussed it and we were really excited about. And so hopefully Boat Jam maybe fills that gap of, like, oh, there was a really neat project that we did for one weekend, and instead of shelving it, we go back and improve it and make it better. There are people in influential roles in studios that don't always agree with game jams because they think that they're just fire and forget projects. And if you can actually show a little more development to say, like, oh, we iterated on this game jam game, we went to it a couple of weekends and we made it a better game. Your professional studio that you go to work for will be all about iteration. Every sprint will be working to build a feature. It'll be tested, and then it'll be refined. So if you can show that you are iterating even on your game jams, that you don't even have throwaway game jams, that you've got ways that you can refine what you're working on, that is another feather in your cap when you go to talk to the studio, to be like, hey, I know how to iterate on a project. I know what it's like to do more than just the fun. Like, the game jam is the fun part, right? You've got boundless blue sky and you come up with a great idea and you spend every weekend on it. But if you go back and then hold your code to task, or think about reducing the size of your assets to make them fit so the game loads faster. Like all of those moments of refinement give you another talking point in your interview process, and give you something to highlight on your resume and things like that. So the Create with Code Game Jam, we're going to wind up hosting another one at the end of this Create with Code series on the Learn platform. There's some great resources on our platform as well if you're doing any Game Jam. And I do suggest that you go back and revisit the Game Jam games that you've done in order to help refine those projects as well, because that just makes it a more polished product when you go to show your work to a studio, when you're talking to a hiring manager or anybody else like that. And that, as fast as I spoke and as long-winded as I am, is what I got. My name is Greg Lane. I'm the Learning Support Manager at Unity, working on the Learn project. Thanks so much for listening to me. The hashtag Unity Tips is a great place to start if you're just on Twitter and you're looking at Unity stuff and you wanted to know more about that. The hashtag The Joy of Game Design is me every day, daily. I also put a write-up of the first 50 because I'm closing in on 100 right now. The first 50, I've got a blog on Gamasutra, which is an industry news source. I don't know if everybody knows that. Gamasutra.com is got articles written by developers and by the news outlet there itself. It's got a job board, so if you're looking for jobs, Gamasutra.com is a great place to be. Workwithindies.com is also a great place. areweinYourState.org is a government website that tracks all the game studios and colleges by congressional district for some reason. Anyhow, all great resources for you to be on your career journey. Because like I said, I made the move from New York to Maryland. You might wind up moving several times in your career if you're hopping studios and stuff like that. And it's always good to know what's in your area. When I first started looking for jobs, I wound up looking for every studio in Maryland because I knew I wanted to end up here eventually. And I just applied everywhere. And then I looked at New York and applied to everywhere in New York, and I was lucky enough to get one interview out of all of those studios at that time. So it takes a lot of applications. Like I said, my degree is in writing as well, so I don't know if that threw people for a loop. But a piece of advice that they gave us writers when we were finishing our writing degree was they said you should have enough rejection letters to wallpaper your apartment, because that means that you're putting your work out there, and that means that you're trying, and the more it's sort of a numbers game. The more no's that you get means that you will get a yes down the line. It's tough. It's tough to not hear back. It's tough to hear no. It's tough to go on an interview and have it and feel like it went really well, and then be told they're going with another candidate. But that's fine. That just means it's not for you yet. You are going to wind up somewhere where it is meant for you. So I wish you all the best in your career. I see one more in the chat here. For the Unity LinkedIn badge, how do you see it regarded by some of the local game studios? That's a great question. I haven't talked to any of the local. That's not entirely true. I've talked to some local studios about art-related stuff, though. I will have to find out. I know some recruiting people that I can talk to, but I do know that recruiters look at your LinkedIn page, all of your socials. They will do a social media scrub of you when you apply. So it is more than just the resume that you send them. So they will certainly scour your LinkedIn page. They'll ask you. When I was interviewing for the Unity job, they asked me questions about things that were on my LinkedIn page. So I know Unity looks at it, and that's before they had this program to post badges there. And I know that the hiring director at one of the local studios here in Maryland did a social media profile scan, so they knew what your Twitter was, they knew what your Instagram was, they knew if you were a good culture fit, they knew if you were talking about games in the space in the right way and that kind of stuff. So all very interesting things. That sounds similar concept to an AWS cert, but I've never seen anything like that before. It is brand new. There are certifications that you can get through Unity. There are paid certification courses. There are entry level, mid level, senior level. That you can also pay and take a test by Certiport, and then include that as well. That's more refined. That's got an established history with studios and applications, so they know to look for that. These badges are fairly new, so it is a good talking point to like open that conversation up. In the chat says, are cover letters necessary component of getting your foot in the door for an interview? It depends. I didn't write a cover letter for Unity, although they came to me. I've written cover letters for other things. Oh yes, cover letters are important. Sorry, my brain. I had to reset my whole brain and then cycle through everything that I knew. When I applied to be a QA tester for Big Huge Games, one of the questions they asked you was, "Hey, can you write a bug? Can you write a bug in a game that you've experienced? How you experienced it?" They want you to do that because as you are a QA tester, you're going to be writing a lot of bugs, and to write a bug, there was a bug that I noticed in Dominations, in the live game that they put out. So A, not only did it tell them that I'm actively playing the game that they released, B, it told them that I'm approaching it with a critical eye and looking for the corner cases or edge cases, whatever you want to call it, that exist in their programming. I'm already essentially doing the QA job that I'm applying for, and I was able to write that in my cover letter. So I think that's what really helped me get that interview. So yes, cover letters are important. Full stop. Play the game of the studio that you're applying to. Full stop. Especially if it's free to play. Play the game of the studio you're applying to. If you can't play it because you don't have the right phone, if you don't have the right hardware, if it's like a VR game or whatever, if it's a financial thing, don't break the bank trying to play every game that for every studio that you're applying, unless you're keeping a list and then going to do something similar that I did. Don't break the bank. Go to then Twitch and watch other people play it so that we've got a good foundation of what's going on in the game so you can talk at an elevated level. That sort of same way that it was discussed of like it might not be a lot of on-the-job training. So like if you can go and talk about like regions of the game or some other bit of player experience, that goes a long way to already speaking the same language and being on the same team. So that's a good question. And then the follow-up question, which I didn't read until now and already subsequently answered, I guess, was, and if so, what's the extent you go to research the company projects before you write one? Yeah, exactly that. Play their game. Play the game of the studio you apply for. Watch it on Twitch if you can't play it. Do both. So yeah. And I think that's all I've got. Thank you so much for hanging out with us here in the chat. Thank you so much for to UMBC for allowing me to speak and yammer on as unrestrained and as long as I have. I hope that you all have had a lovely day with the showcase today. The digital media, and I've lost the name of it now, and I'm going to screw it up, and I'm so sorry. But thank you. Do I need to kick this back to anyone? I can hop over to. Oh yeah. Sounds great. I'll stop sharing that. Thank you.
All right. Well, that concludes the Digital Entertainment Conference for today. I hope everyone's gotten a good learning experience from all these speeches. And thank you to all of our speakers who have generously donated their time to speak today at the event. Later, broadcast of most of the speeches will be posted onto the YouTube channel for playback. Keep an eye out for that. And if you're looking to follow the UMBC Game Developer Club for any other sort of events, I'm going to post a link to the UMBC Game Developer Club Discord in the YouTube chat very briefly. Oh. that concludes the DEC. We'll have one next year as this is an annual event. Stay tuned.